How's it going? My name is James and welcome to this Python beginner course where we're going to go from potentially having no pre-existing understanding of how programming in Python works to having completed an absolutely insane Python project and ultimately you having the skills and knowledge you need to feel comfortable and confident building out your own absolutely amazing projects in the Python programming language. Now, I love Python. I think it's absolutely wicked. Just the other day, I was reading my favorite series, the Wheel of Time series, and Robert Jordan, the author, has the craziest vocab. I thought my vocab was good, but boy, this guy really blows it out the park. And I wanted to go through all of his books and find all the amazing descriptive words that he uses, define them, and learn them. Now, the problem is, he's got 14 books and each book is like 1,000 pages long. And I was like, how on earth am I ever going to be able to do this? Well, Python was my answer. I spent an afternoon writing some Python code that could read the PDF files, read in all the words, find in every unique word, and then could go and determine whether or not words were classified as advanced. It could define all of the advanced keywords. And then I wrote a script that was a spaced repetition algorithm that would test me on all of these words so that I could, gradually go and improve my vocabulary. And once again, this was just an afternoon. Python could do all of it, and it was an absolutely amazing process. I think that in each book, I found there were approximately 14 to 15,000 words, and I probably came away with nearly 200 unique advanced words from each book that I wanted to learn. And that experience has actually inspired the projects in this course, which is super cool. Now, a bit about this course. First up, it is totally beginner friendly. If you have no experience in programming, Python is a brilliant introduction. If you do and you just want to learn Python, add it to your inventory of skills. This is the course for you. This Python course will also teach you all the core concepts and foundational knowledge that you need to ultimately go on and become an absolutely brilliant Python developer building all sorts of amazing applications using the Python programming language. You will feel extremely confident and comfortable with any Python challenges you are presented with. And if you stick around to the end of the course, you will also be left with a Python codebase that you could upload to your GitHub profile, and it would just be super impressive to prospective employers. And it's also a great reference point. You can refer back to it because it's a great demonstration of all of the core concepts that you need to be familiar with in Python. Now, the course itself is broken down into 2 chapters. Chapter 1 is an introduction to all of these concepts. It's a pretty gentle progression, so it should be pretty easy to digest all of the material. You by no means need to remember everything. That's what Chapter 2 is for. We're going to put the theory into practice by building out this project that I discussed earlier. It's going to be a spaced repetition game where a user can start up the game, test themselves on all of these words. If they get it wrong, they have to start from scratch. We print out a score. And we're also going to code out all of the spaced repetition algorithms so that you get a whole lot of experience coding some reasonably complex stuff inside of Python. This is just going to be great to consolidate all of the knowledge from Chapter 1 inside your brain so that in future you can go off and become this ultimate Python whiz. Now, cool thing in this course, there's absolutely no prerequisites. So anyone should be able to complete this course. We're going to start off from scratch, as I said earlier, so everything is taught from the ground up. I'll introduce you to everything you need to know, and if you get stuck at any point throughout the way, my code is linked in the description down below. The GitHub for this project is available there, so at any point you can compare your code to mine, see what's going on if you have any errors, and even better, for any questions, qualms, or queries you may have, if you just head over to the Issues tab, you can create an issue on that repo, say what your question might be, and either I myself or someone else will respond to you and help to clarify any misunderstandings or, questions you may have. So it should be a wicked course. I'm very excited to have it live on the channel. It's something I've been meaning to create for ages. I think Python is brilliant for anyone to know. I just think that if you wanted to automate your job, if you wanted to do 101 million different things, Python is the language. As always, if you enjoy the course, don't forget to smash the like and subscribe button so that I can continue to feed Doug a healthy diet. And with that all said, let's dive into Chapter 1, an introduction to Python. Alrighty, it is now time to dive into Chapter 1, which is going to be an introduction to Python. Now, to be able to complete this course, you're going to need two things installed on your device. Number one is a code editor, and the code editor that I like to use is Visual Studio Code. Super simple to download. The link for download is available in the description down below. And when you download it on your device, you should be able to open up a window that looks vaguely resemblant of this. Here's some Python code that I was literally writing earlier inside of Visual Studio Code. All you have to do is select your operating system, and that should be good to go. Now, obviously, this is a Python course, so the second installation we're going to need is Python. Now, the link for the Python website is also available in the description down below, and downloading it is very straightforward. All we do is we come over to this download tab and select our operating system and click download, and that is step one. Once Python is downloaded, we now need to install it. Now, the installation process is ever so slightly more complex, and so what I've done is created a very comprehensive guide of step-by-step instructions that you should follow to successfully install and verify the installation of Python on your device. It's once again not that complicated, but it's good to refer to. There's just a couple of steps, operating system specific, and at the end you should be good to go with Python on your computer to complete this course. Now, this guide is available in the GitHub repo for this course, which is linked in the description down below. Just check out the readme.md file and follow the Get Started with Python section of the guide. So now that we have Python installed on our device, it's time to dive into the code. And the first thing we're going to do is begin by opening up a blank window of Visual Studio Code. Now, if you've just installed it, your theme might look a bit different, but overall, it should be pretty much equivalent. And step one is to open up a project directory, and we'll do that by clicking this open key right here. And we're going to navigate to the project directory where we're going to have all of our code. Now, I keep all of my coding projects inside of a folder called GitHub, and just here I already have a folder called Python Beginner Course. Now, if you don't have that folder, which you probably don't, you'll need to create it. And once created, just select that folder and click the open button, which is behind my head. That's going to go ahead and open up this project inside of Visual Studio Code, and we can confirm that we're in the correct project directory because over in our Explorer, up here we can see our folder Python Beginner Course. Now, your folder will be completely blank if you have just created it. I already have two files in it. One is definitions.json. That's a JSON file with a whole lot of words and definitions, and that's going to be important for Chapter 2, the project portion of this course. I'll show you how to get that on your device later when we enter Chapter 2. And then we also have a secondary file, which is the readme.md. Once again, you can copy this onto your device from the GitHub repo. It's not necessary, but it does contain all the instructions that we will have used to get Python up and running on our device. Now, with those two files aside, it's time to create our first Python file. Now, you can either do that by clicking this little plus create file button right here, or we can right click and create a new file, and I'm going to name this file chapter_1.py. Now, .py is the file extension to create a Python file, and we can see that Visual Studio Code has recognized that it's a Python file because it shows the little Python icon. Now, if I hit enter on that, that is going to open up that file from our project directory into our little text editor, where here we can go ahead and write a whole lot of Python code. Now, just before we dive into the code, first, I just want to give an analogy for what Python programming actually is. And in my head, I like to think about programming as just writing out instructions, except where most instructions are typically written for humans, when you're programming, you're instead writing out instructions to be read by a computer. And the programming language is literally just the language and the set of rules that create a syntax that the computer can interpret and consequently execute. So the process is creating our instructions, all of our code, writing out these instructions in Python, and then part two is obviously executing them and getting the computer to run these instructions. Now, if we think about a common instruction sheet that humans write out, it's a recipe for cooking something. And at the end of the day, coding in Python really isn't that dissimilar. As I said earlier, when we write out a recipe, we're writing in English. And when we're writing instructions in Python, instead of English, we're now using a Python syntax. Now, Python is what's referred to as a high-level language, which means that the syntax is pretty understandable to humans, even though it is predominantly written to be interpreted by a computer. And that makes it really easy for beginners to get up and running with Python, and it's just an absolutely great language to learn. Now, how writing out these instructions works pretty much exists in three parts. Number one is variables, number two is data types, and number three is logic and operations. And collectively, they create Python. Now, our first objective in our Python file is to follow an age-old convention that is typically the first thing someone does when they're introduced to a new programming language. And what that is, we have to code out an instruction that when executed, our computer is going to talk to us and say the phrase, "Hello world." Now, we've got our Python file open just here, and we're going to start off by literally just writing out the phrase, "Hello world." Now, when I type that in, I can see that everything goes red. And we're in a text document, squiggly underlines normally might not be the end of the world. It maybe means you have a spelling mistake. Inside of a programming language or a Python file, they mean that you have a syntax error. Now, once again, the syntax is just the rules of the language. So in this case, we've broken some of the rules, and if we tried to run this file, the computer would not be able to understand our instructions. Consequently, we wouldn't get anything executing. And so the first thing we're going to learn about is what's known as data types. When we're writing out stuff inside a Python file, we have to ensure that the data we type out or add to our file fits within one of the core data types. Now, a data type is literally just a type of data. For example, if we look at a number, here I have a number. If I save that file, I don't get any red underline. And that's because the number data type is shared by both humans and Python. So that's super simple. Python knows how to recognize a number. Now, when it comes to writing out sentences or phrases or names, I could have my name is James, and I could also have the phrase "Hello world," which is the phrase that we're trying to get our Python file to spit out to us, say back to us, kind of like a parrot. What we have to do is create them as what's known as the string data type. Now, the string data type comes from the fact that you're literally stringing together a whole lot of characters. Could be alphanumeric. For example, I could replace this E with a 3. My name is James. And so we need to take this from being plain human text, which Python can't interpret, to being a Python-friendly sentence known as a string. That is data type number 2, the string. So when we're writing out series of characters, strings of characters, or sentences in Python, the way that we create these strings is we take our sequence of text and we wrap it within the quotation marks. And we can either use the single or double quotation marks. We can see we have the closing one at the end and the opening one at the start. And when we're using these types of quotations, we cannot split this onto a separate line. A big part of syntax inside of Python is the indentation, which we'll learn all about shortly. And that means that Python is also relying on us using the correct structure inside of our Python file for the syntax to be correct. So I've now turned this series of characters into the string data type. Python understands that that is just a sentence, it's just a string of characters, and we can see that squiggly red underline has gone away. Now, if I wanted to do that with hello world, I could do exactly the same, except this time I'm going to use the single quotation marks, and we can see now that our red squiggly underlines have gone away, and that is the string data type. Now, there are a bunch of data types available in Python. We're going to look at all of them in chapter 1, but just before we move on to number 3, I want to introduce a really cool concept which is common to every single programming language, and it's what's known as a code comment. Now obviously, as I said earlier, we're writing out instructions using the Python syntax so they can be interpreted by Python and consequently executed. But sometimes when we're writing out a whole lot of code, if it becomes really convoluted, we need to add human-friendly, basically descriptions of what's going on so that our Python code or any code doesn't just become mumbo-jumbo that can't be understood by anyone except for the person who originally coded it. The number of times I've gone back and looked at an old code base and had to be like, what on earth is going on, is not insignificant, and that could have been fixed if I had left myself a whole lot of code comments, which are basically just English notes or whatever language you might speak, that you can leave inside of these Python files, but they will be ignored by the computer when the file is executed, and consequently they won't break anything. Now the way that we create a code comment is using the pound key, and we can see that it's grayed out, so it's kind of like as if it were invisible to the computer. And anything I have on this line after the pound key will be invisible to Python. So I could say here, this is the number data type. And now that doesn't create any red underlines, there's no syntax errors, that is safe. We can happily do that, and I now have an English note for anyone who looks at this code base, they can understand that this is the number data type. I could leave one here that says this is a string data type, brackets, a string of characters, and they could be alphanumeric. And above both of them, I could leave another comment that says 1.0 data types, and that is the topic that we are currently covering. So that's super cool, and to get practice with code comments, what I like to do as I'm learning, whenever I hear something that is being taught to me that I really like, I'll literally leave it as a code comment inside of my code base because everything is just in one place and it's a really good practice. So after that, we're going to introduce a new data type, which is equivalent to, if we go back to the recipe analogy, when we list out all the ingredients that we need. Essentially, it's creating a list that is interpretable to Python. So this is the list/array. Array is the more technical name. Data type. Now the way that we create a list in English would be to say eggs, comma, bananas, comma, milk. Now obviously that's not going to be friendly to Python, and as such we get a whole lot of squiggly underlines. Now the first thing we would need to do to make this friendly to Python is, because we're using alphanumeric characters in a sequence or a string of alphanumeric characters, we know that they need to be these string data types. So I could go ahead and wrap each of them inside of the single or double quotation marks, and now we can see that the red underlines have gone away and we just have 3 strings. However, as they're currently listed, a human might understand that this is a list, but the programming language does not. So the way we create a list of elements, entries, values, data inside of Python is we wrap it inside of the square brackets. So now here I have a list or an array that contains 3 entries. So I've listed out 3 items inside of this array, and they are contained within the square braces. Each element is separated by a comma, and the 3 values within the array are all of the string data type. I could even throw in a numeric value as a 4th entry, or I could even throw in an array within the array, and this is what's known as a nested array. Now one thing I want to point out, in this introduction, this chapter 1, there's going to be a lot of information presented to you. Don't worry if you don't retain everything that I say. We'll come back to it in chapter 2 and really work on consolidating a lot of the knowledge that we have been introduced to in chapter 1. That way, by the end of the course, you should feel comfortable and confident programming in Python. Anyway, this is the list or array data type, contains a series or sequence of values that can be of any data type themselves. Now, one thing to know about lists is that they are indexed. So just like when we write out a list to go to the supermarket, we have the first element on the list, the second element, the third element. You know, number 4 item on the list is to go to the gym, for example. That works exactly the same inside of Python. So this entry is the first entry inside the array. However, one thing to know about programming languages is that many of them actually start off from the 0th index. So as much as this might be the first element in the array, this is index 0. So it's as if we write our list starting off from 0, then 1, then 2, then 3. And that's just something important to remember. And then the cool thing about that is that later I could try to access the value at index number 1, and that would return to me the string bananas because that is at the first index, even though it's the second entry. So that's super cool, and there's loads we can do with lists, as we will see later. Now underneath that, we have the 4th data type, but before we jump into that, we actually at this point have enough information to complete our original objective, which is to get the programming language to spit out hello world. So what I'm going to do in here is add a code comment, and that just says sub objective print out the string hello world. Now in Python, if I go ahead and save this file, currently we have no red underlines, which means that all of this is syntactic gold. Python can absolutely interpret what's going on. It doesn't mean it necessarily does anything, but we can find out by actually going and running this file. Now the way that we do that is from the terminal. And the way I like to open up a terminal inside of my Visual Studio Code is with the Control and backtick keys. Here we can see that popped open a terminal. Now you can open up a terminal a number of ways. You can do it via the folder options, look for terminal and new terminal, or you can use the Control and backtick key. If you want to know all of the key shortcuts I use inside of VS Code, I have a link to all of them explained in the description down below, so be sure to check that out. And the Control and backtick shortcut is available in there too. Anyway, this opens up a terminal instance for us, and just here we can see that we are in fact inside the correct project directory. Now from the terminal, that's where we tell our computer to execute all of these files, run all of these commands. And the way that we execute a Python file or a set of instructions written in the Python programming language is we use the Python command. Now on my computer I have to use Python 3, some people just have to use Python. See which one works. To figure out which one works for you, try typing Python or Python 3 -- version. If you hit enter on that, that is going to print out the Python version currently installed on your computer. If I just try use the Python one and type version, we can see I didn't find that command, so I will be using Python 3. Now that we confirm that Python is successfully installed on our device, and once again, if that's not working for you, be sure to refer to this file inside of the GitHub repo, which is linked in the description down below. Also, if you do check it out, if you could star the repo, love that support, super appreciated. Anywho, now that I have confirmed that I have access to Python 3, I can go ahead and run Python 3, and I just tell it what file to execute. Now, because chapter 1 is available within the Python beginner course, it's as simple as typing out chapter_1.py, and if I hit enter, that has now executed the file. If I had some values in here that were incorrect syntax, invalid syntax, and I then went to re-execute the file, I can use the up and down arrow keys to find old commands. If I re-hit enter, we can see we get an invalid syntax error, and that broke. Anyway, with our correct syntax, we can now run these files. However, nothing came out from our terminal. We couldn't get our file to speak back to us. Even though we have the hello world data type, it's a string, it's happy Python, we have to now instruct our Python to talk to us. And the way that we do that is with the print command. Now print is your best friend. You will use it all the time. And it's essentially a reserved keyword inside of Python that is associated with a particular directive or instruction, which is to print to the terminal or log to the console. Now what we do is we use the circular parentheses to incite this action, and then whatever is inside these circular parentheses is what gets output to the console. So in this case, I could type out hello world, just like that, and that would almost work. If you remember, when we have a string of characters or a sentence, we have to wrap it inside of the quotation marks. And now that is happy Python, I can remove it from just there. And when Python executes this file, it's going to read the instructions from the top down. And when it finds this line, it's going to say, okay, my awesome coder wants me to print out some information to the terminal, to the console, and whatever is inside of the circular parentheses is what they want me to output. Now, technically, print is known as a function. It's another type of data. It's another data type, and we will learn all about functions a bit later in chapter 1. But for now, we're just going to have a quick introduction to the print function because it's super handy and it's part of our first objective, which is to get our Python file to talk to us. So now that I have this line, I'm going to re-execute this file. I'm going to scroll up to my last command using the up arrow key, hit enter, and now we can see just here, our Python file has spoken to us and it said hello world. Now if you got that to output, congratulations, you are now indoctrinated into the realm of Python. Congratulations, that is a huge achievement. And with that complete, we can move on to the next data type, which is known as an object. Now just before we do that, I want to clarify that all of these data types currently don't actually do anything, but they are super important for writing safe Python, and we're going to see how we can put them all to amazing use later in this course. So we just learned a bit about lists, and we got something to print to our console. But what if we wanted to create a list, except instead of using an index, a numeric index to track all of our entries, we wanted to use a different term. And a good analogy for this is a dictionary. In a dictionary, we have a whole lot of definitions that are associated or found by, essentially indexed by, the name of the word they're associated with. Well, there is a data type for that inside of most programming languages referred to as an object or a dictionary. Now, in here, this is an object data type / dictionary. To create a dictionary, we use the curly braces, the opening and closing curly braces, and anything inside here is within our dictionary. Now, as with the dictionary analogy, where we have a key or a word and its associated value, which is the definition, inside of a dictionary, we still have the keys, except they could be anything, and the values don't have to be definitions, they could be any value of any data type, and together they are referred to as a key-value pair. So with a dictionary, what I'm going to do is enter it onto a new line, and one thing I'll note is that, arrays can also be entered onto a new line because that's almost more equivalent to a traditional list. But the point is, within this dictionary, I can now create my key-value pairs. For example, I could have a key where the keys are created as strings, so we need to use the quotation marks, and the name of the key is going to be name. Now to associate a key with a value, we use the semicolon, and then the value has to be a valid data type. In this case, it's going to be a string that just says James, and then I can comma separate key value pairs within a dictionary, so I can add the comma, and then on a new line, I could have a key age, and that could be a number or numeric data type that says 28. And this is the dictionary data type, pretty straightforward. And this could be a dictionary that refers to an individual. In this case, it kind of has some key value pairs that describe a little bit about me as a person. Dictionaries are incredibly common. We will come across them a lot. And the cool thing about them is that later, when we label all of these data types, we assign them to a variable, which is going to be a super cool process that we'll learn all about. We can then access individual keys within the dictionary to access their associated values. And that is going to be incredibly helpful for about 1 million different things that we're going to be doing inside of Python. So that is the object data type. And with that complete, let's just take a quick recap before we move on to the next ones. So data types inside of Python are safe ways for us to store information. And a big part of programming is saving information and then manipulating it on a scale that a human just couldn't do. So we need data types to provide or present this information in a manner or syntax that is friendly for Python, that can be understood by the computer. It follows the rules, the syntactical rules of the Python programming language. First up is a number, and that is a data type that is shared by both humans and Python. So we both understand this as a number, and as such we can just write it out, no strings attached. Number 2 is the string data type, and that is for when we have sentences in English, but we want them to be friendly for Python. It's just a string of alphanumeric characters. We string them together into a sentence, and we create a string by wrapping it inside either the double or single quotation marks. We also learned about print, which is a function that we're going to learn about shortly. And essentially, print is a reserved keyword where it tells our Python file to speak to us inside the terminal, to print out some information. And we invoke the print function with the circular parentheses, and whatever we have inside those circular parentheses needs to be a valid data type. In this case, we have a string of characters that says hello world. And these strings are what's known as an argument, and when Python reads this line and executes it, that's what gets printed out to the terminal. Underneath that, we had a data type that is resemblant of a list. It's literally called a list in some cases, also known as an array is the more technical name. And essentially, we just have a whole lot of values that are valid data types listed one after another. They're comma separated, and they are contained within these square braces. This is one list. Each entry in the list is indexed by a numeric value, where the indexing starts off at 0. So the first entry in the list is at the 0th index, and that is known as a 0th indexing system. This is the second entry, and it is the first index, and I can then at a later stage access this list, specifically the value at, for example, the first index, and that would return to me the string bananas. After that, we have a dictionary, which instead of using a numeric index, it has a key. So values are indexed by a unique key. Now, keys within inside a dictionary have to be unique, and it literally can be thought of as a dictionary as a good example of, this kind of data type, where we have a word that's a key, and it's associated with a value. In the case of a dictionary, a literal dictionary, it's a definition. And we look up values or definitions by their key. So I might look up the word awesome, and I would find the associated value, which is the definition. Together, these create key value pairs, and they can be comma separated to have many different key value pairs within inside one dictionary. The values must be valid data type, and they are contained within these squiggly braces, and that creates our object, where the object is the technical term for a dictionary. So with that little recap done, let's move on to the next one. It's called a Boolean. Now, Booleans are super fun. I absolutely love the word, and essentially what it represents is a true or false. Now, true and false are super important inside of Python because a big part of programming is logic, and logic relies at its very core on true or false statements because they can be represented as binary, a 0 for false, a 1 for true. That's how hardware is actually created. Anyway, the Boolean can be literally either a true value or a false value. And it's as simple as that. The true is the true and the false is the false, and they collectively are known as the Boolean data types. Later we'll learn about truthy and falsy values, which essentially are just different data types when converted to a Boolean, either evaluate to true or false, but that's something we'll touch on shortly. After that, we have a data type known as none, and none represents the absence of information. So that's relatively straightforward. There are some utility cases where we find ourselves needing a particular value that for the minute has nothing associated with it, but potentially later might have something associated with it. So for the minute, we just define it as being empty, and that is associated with the reserved keyword none. And with that done, we have now completed our chapter on data types. These are all of the data types that we will be using inside of Python to create these absolutely insane Python projects. So now that we have all these data types, what comes next? Well, it is now time for me to introduce you to a concept known as a variable. Now, just at the top where we have data types, a data type is a type of data that is friendly to Python. This chapter is 2.0 variables, where a variable is a label for some data. It's that simple. So if we go back to our analogy of a recipe, let's say, for example, you go to the ingredients that you need, you might find that you need 3 eggs. So if I were writing out the set of instructions, I could just have the value 3, but if someone is looking at my code, or even if Python is trying to understand this, it doesn't really make a lot of sense. But what I could do is I could create a variable called number of eggs. And I could say that is equal to 3. And suddenly, this sentence makes sense in English. However, in Python, it looks like we've got a syntax error. Now, what I have on this left side just here is our first step to creating a variable. It's obviously not complete because we have a syntax error. But the variable is once again just the label to which we associate a value. Now, there are 1,000,001 reasons we need to use variables, specifically because when I associate data, I can refer back to it later. I can modify the value associated with it. I can run manipulations on it. Variables are going to be so important inside of Python. And one of the rules you need to know to create them is that first and foremost, they cannot start with a number. Variables must be created using values from the alphabet, characters from the alphabet. And the second thing is that they can't have any spaces. Now, inside of Python, the best way to create a multi-word variable without any spaces is using what's known as snake case. Now, snake case, essentially, the spaces are just replaced with underscores. So that's still incredibly readable, and now our syntax error has gone away, and this is a variable. Now, one thing to note is that it's not a string. As much as it might seem like a sequence of characters, because it's not a data type, it's instead a variable, we don't need to wrap it inside of quotations. If I had a second variable, let's say I had a string hello world, what I could do is I could associate this or assign it to a variable that's called my string. And just like that, I have a variable, or I have labeled this particular string so that I can either refer back to it later very easily, or it's just clearer code. Suddenly it's understandable that this string right here is my special string. Now, the cool thing about variables is that we can do all sorts of neat stuff with them. For example, I could print out the number of eggs, and I could print out my string. So we're once again going to use this print key, which is going to output inside of our terminal when we run this file. And instead of having to enter the values as arguments to this function, I can just refer to them by their variable name. Now, one thing I've done here is I have added 2 arguments to my print function, and I've just comma separated them. And you can do that inside of a print. If you want to print a whole lot of stuff, you could either use separate print statements, or you can just have one value and then comma separate it from the second, and so on and so forth. Keep doing that for ages, and you'll just print out all of these entries. Now, let's say I wanted to print the number of eggs. What I actually could have done is just typed 3. But what if we ended up having 4 eggs? Well, now I would have to change this value here, and I would have to change it here. And so you can imagine if we had a massive Python file, it would be easy to introduce inconsistencies in our code. And so that is just one of the many examples where having the value assigned to a variable that we can then change later makes this process way easier. If I just refer to it in future by its variable name, now I would only have to change the value here once, and all the rest of my code is absolutely sweet, because when we call on this variable name here, it's just going to look up what was originally or previously assigned to it. Variables are incredibly helpful. We will learn all about them throughout this course. But for now, just think of it as a label for a data type that we can refer back to later, where instead of having to remember the values for everything, we can just refer to them by their variable names and consequently access the values associated with them. One last example is that I could run a mathematical operation just here. I could print out number of eggs times 2, and this code is going to print to the console, output to the console or the terminal, and it's going to find the value associated with number of eggs and multiply it by 2. And so if I run this file, we can see that we still print hello world from above, but now we also output 10, and that's because that's 5 times 2. So that is a little bit about variables. Now if I wanted, I could go back to all of these other things and create variable names for all of this. I could call this one person and set it equal to this particular data type, and suddenly that's just a bit more descriptive. Now when I refer to the person in future, I know that I'm referring to this dictionary, which has a whole lot of key value pairs that describe the person. This list could be referred to as shopping underscore list, and that is now equal to my array. This string, well, we've seen how we can assign values to a variable when they're of string data type, but that's just a few more examples to describe how variables work. So now that we know a bit about variables and data types, we can dive into logic and operations inside of Python. And this is where the true magic of programming is unlocked, because with logic and operations, we can do stuff that would literally be impossible for humans. For example, just recently when I was inspired to create the project for this course, behind me just here, I have all the books for the Wheel of Time. I love the series, and one of the things that I love about the author, Robert Jordan, is that he has crazy vocab. There are so many words that I have to look up that I'm just like flabbergasted by how amazing they are. And I wanted to write some code that would read every single word in all of the books and basically pull out all of the impressive words that I didn't know so I could consequently go and learn them. And some of these words are inside this definitions.json file. Now for me to go through all 14 books and find all of these unique words and consequently define them would take me 100 million years. But I can do it with Python in about 15 minutes because I can just write some logic that executes these crazy instructions faster than I can possibly count. And that is the power of Python. And that is all to do with logic and operations. So here we're going to have a chapter. This is a code comment called Logic and Operations. And that's going to be 3.0. Now the first thing to know about logic and operations is a concept known as an if-else. So just here, I can write the keyword if. And what I can do is I can provide what's known as a condition. So essentially what an if block does, this is an if block, so here we can have an if block, and that essentially is just if condition is true, execute this code, otherwise skip it. So let's say I have number of eggs, this variable, and let's say I wanted to only print some code if the value of number of eggs was greater than 5. So what I would do is I would say if number of eggs is greater than, using the greater than key, 5, and then what I do is I use the semicolon and I enter onto a new line. Now just in here we can see that my cursor is tabbed or indented by one tab across, and all code in here is scoped. Now when code is scoped, it means that it only exists within the realm of this if block, or whatever block of code it might be created within. So in this case, when I have this indented line within this if clause, whatever I write in here before I go back to the primary or default indentation only exists within this if block. So let's say I print, for example, a string that says you have more than 5 eggs. That kind of makes sense. We have an if block that we only want to execute if we have more than 5 eggs, if the value associated with the variable number of eggs is greater than 5. Then we print this command, you have more than 5 eggs. So what's happening here is Python is going to read this if block. it's going to check this condition. If the condition evaluates to true, we're going to enter inside the if block, where inside is anything that is indented, specifically by a 1 indentation. If the value is true, we'll print this line. If it evaluates to false and the condition turns out to be false, which is the Boolean logic just here, it becomes a false evaluation, Python is going to skip over this scoped code. So just down here, what I could do is come back to the traditional indentation, and I could say print we finished, or actually better said, we passed the if block. So now when I run this code, we're going to check if the number of eggs is greater than 5. If it is, we're going to print this line, and then either way, we're going to print we have passed the if block. And because I've gone back to the primary indentation just here, this is no longer scoped code, or better said, it's actually globally scoped. Anyway, let's go ahead and run that file and see what happens. We see we get the value 10, which is from this multiplication print just here. We see that we passed the if block, but we didn't print this line. And that's because currently number of eggs is 5, which is not greater than 5. And because this evaluated to false, this condition evaluated to false, we didn't enter or execute any of the code scoped to this if block. Now if I were to change this to 4 and rerun this code, we can see that we do in fact have more than 5 eggs. So now when we ran the code this time, we found that 5 is in fact greater than 4, and I technically should have updated this to be 4. And one important thing to note that I haven't said yet, that I probably should have said ages ago, is every time you make a modification to the file, save it before you re-execute it. Save the file before you re-execute it. Otherwise, the Python will only read the previous save, and any changes you may have made will not have been recognized. Anyway, I've saved this file. Number of eggs was greater than 4, so we entered the scoped code, we entered the if block, and any code on this single indentation is the code scoped to the if block. Once we finished that, we came back to the general global scope and we executed this following line. Now, if clauses are super cool because we could also have just here a secondary if clause that says if, let's get a little bit more complicated, name in person. Then we have the semicolon to finish the if clause. Now, if we remember, the variable person refers to this dictionary object just here. Now, this syntax, name, we refer to a key. If that key is inside of person, the dictionary person, evaluate to true. So this condition just checks if the person dictionary contains the key name. If name is in person, if the key name is in person, what I could do is I could print, and I can access the person object and specifically a key inside of the object by using these square parentheses, and I can index a string called name. What this syntax is going to do is it's going to access the person dictionary and look up the key name, where the key is provided as a string inside of the square parentheses, and it's going to return the value associated with that key. And we can do this because this line will only be executed if we've already confirmed that the name key is available inside of the person dictionary. So if I were to go ahead and run this code, I would expect it to output James, and we can see that's exactly what we get. We checked if name was in person, it is, and so consequently we can print person and specifically the name key. We can look up the name key within the person dictionary by providing it as a string inside of the square parentheses. That's how we look up values inside a dictionary. We'll learn all about that syntax later, but for now, it's a cool way that we can just print out some values inside of a dictionary. Now, the extension to the if block is what's known as the else block. And the else block is written on the same level as the if block. So if the if is here, the else is here, and they are connected. And the else block is an otherwise condition. So just here we have the keyword else, and then we have the colon, and then we enter, and then we have some code that is scoped to the else portion of this block. For example, I could print a statement that says the key name is not available within the person dictionary. That kind of makes sense. If this evaluates to false, the key name is not available inside the person dictionary. And so this is false. We skip this code block and we instead execute the otherwise or the else condition. So if I were to run this code, this wouldn't print because name is inside person. Anyway, we've saved that. Let's go ahead and run that file. I'll clear out my terminal, run python 3 chapter_1.py, hit enter, and now we can see we didn't print this else block because we instead printed the if block. The if was true, so we didn't need the else. If I came up to my dictionary up here and actually just removed this key, which I can do very simply by throwing a pound in front of it, that comments out that line and hides it from the rest of the world. So it's essentially invisible to Python. And now when I rerun my code, we can see that instead of printing out this name, because name is actually no longer inside of the person dictionary, we instead printed the else clause. And we got the output, the key name is not available within the person dictionary. So else blocks are super important. They're very common inside of code. And all we have to remember is that it's if, then the condition, then the colon, and then we have some scoped code, which is one tab indented inside that if block. And then after that, we can optionally chain on an else block to be associated with the if block. Now, if I had that indented, it would be a syntax error, and that's because indentation is an important rule set to follow inside of Python. So we just have to make sure that the else is at the same level as the if, and then the scoped code is a single tab across. Now, a lot of the syntax errors will typically just be a tiny error inside the indentation, so it's just super important to be aware of. One thing you can do at any point throughout this course is obviously compare your code to mine by checking out the GitHub repo. All of my code is available there. I could do one more example of an if-else block. I could say if the string bananas is in my shopping list. Let's just confirm that it is. Bananas is right there. So we would expect this to evaluate to true. And then I use the colon. Then I have an indented scoped code block for this particular if clause. And I could print out need to get bananas. And then I could have an else clause that says else then colon. And that just says don't need bananas. And that's just another example of an if-else block. So they are super handy, and that is really good for conditional logic, where we only want to run some code depending on a particular condition. If something is true, do this, otherwise do that. Alright, so we've just learned a little bit about the if-else clause. If condition, do X, otherwise do Y. And it's super helpful, and we will be using it a lot. Up next is what is called the logical operators. Now there's two in particular. One is and the other is or. And these are very important to logic as a concept, and they come in handy in a number of different places, such as in an if block. For example, let's say I had an if clause that said if number of eggs is greater than 5. And in that case, I want some scoped code that says print we have more than 5 eggs. Well, now, what if I also wanted to make sure that we had less than 20 eggs? Well, what I could do is I could throw in a nested if block. So I'm going to put an if block within an if block, and this is going to say if number of eggs is less than 20, and then I hit enter, I tab across one more, and in here I say, okay, we also have less than 20 eggs. So the egg range is between 5 to 20. Now, if we take a second to understand how this is going to work, we're essentially trying to get to this last condition, which is only going to be run if both of these if conditions are true. If the number of eggs is greater than 5, and when we hit this line, if the number of eggs is also less than 20. If number of eggs was 4, then we wouldn't even enter this if block, and we'd skip to the code below. And likewise, if it was greater than 5, but also greater than 20, then as much as we might enter this first block, we wouldn't enter the second nested if block, because as much as number of eggs might be greater than 5, it's also greater than 20, so the second condition evaluates to false, and we would then skip down here. Now that's a whole lot of code, it's a bit convoluted. Can we make it neater? Absolutely. The way that we could do that, let's say our objective is to print this line, which is to confirm that the number of eggs is between 5, greater than 5, and less than 20. I'm going to move it up a line, tab it back, and remove this second if clause, and remove this first print. So let's say we wanted to have code as simple as this. Well, the problem currently is that we're only checking if the number of eggs is greater than 5. So we're going to print this even though we haven't confirmed that it is in fact less than 20. So what I can do is I can use logical operators. Now the and or logical operators are so simple. All I do is I write and number of eggs is less than 20. And just like that, we have combined these two individual conditions into one greater condition using the and keyword. And so what we're going to do is we're going to check if the number of eggs is greater than 5, and at the same time if the number of eggs is less than 20. And only if both of them evaluate to true will we print this statement. So that's an example of where the and keyword is super helpful. Now another example would be the or condition. So what I could do here, let's say we've got this first block that confirms if the number of eggs is between that range. Well, what if we wanted to have a condition that confirmed if it was outside of that range? Well, we could say if number of eggs is less than 5, and I guess technically it would have to be less than 6 because we want to include the value of 5. Well, that would check one side. If we have this golden range right here, the first if block is checking if it's in the middle of those two numbers. This second if condition checks if we're on the outside of one condition. So that would work for 50% of the answers. Let's write the print statement. Print, okay, the number of eggs is outside the ideal range, which is 5 to 20. So this would check half of these conditions. It would check if it was outside of the 5 range or lesser than. But if it was greater than 20, this condition alone wouldn't account for that outcome. So what I could do is I could use the or condition. Literally there's two birds fighting each other just outside. I could use the or condition and say or number of eggs is greater than 19. Now what this is going to do is it's going to do one check to see if it's outside of that lower range, less than the lower minimum, or higher than the maximum limit. And if one of these conditions is true, one or the other, this evaluates to true overall, and we would print this statement. So we could go ahead and test this a whole number of ways. I could just flat out go and run the file, python 3 chapter_1.py, and we see now we print the statement, okay, the number of eggs is outside the ideal range, which is 5 to 20, and that's because I believe it's currently 4. It is in fact 5. And that makes sense because we only run this first condition if it's greater than 5. Now that actually brings me to an interesting point. These lesser than or greater than signs are also known as a type of operator. And if we want to do an inclusive check, currently this just checks if it's greater than, we could literally just say greater than or equal to, and suddenly that would be inclusive of the value of 5. So that's just something cool to be aware of. Likewise, on any of these things, I could say number of eggs is greater than or equal to 19. But if I did that, I would actually have to change the value to 20. So that's a couple of cool concepts. We now have these two logical operators and an or. If we're using an and, both conditions have to be true for the overall to be true. This and that have to be true. If we use the or, one or the other has to be true for the overall to be true. If neither was true, then it would be false in both scenarios. So that's a little bit about logical operators. Now, just if we talk about operators in general, there's a bunch of them. We obviously have the multiplication, times, plus, minus, and all that good stuff. And that is relatively straightforward. So here what I could do is I could have x is equal to 3, y is equal to 4. And now I could print x times y plus x minus y divided by x. And so you can see that these operators, all of these mathematical operations, work just like they would in a traditional calculator. And the one other thing I want to introduce you to in Python is a special mathematical operation called the remainder. Now the remainder operator is the percent. And what it does is it calculates the remainder. So here, if I said the remainder is equal to x percent y, what that's going to do, here we've used the remainder operator, is it's going to run that division. So in this case, x, and I'm actually going to flip these around for the sake of the demonstration, y remainder x. Now if we were to think about how a division would typically work, if we did 4 divided by 3, we would get 1 1/3 as the outcome. And that would be in the case where we use this division. However, now we're using this operator symbol. And what the operator does is it divides the first number by the second number as many times as it can before the remainder or the leftover is a fraction. So in this case, 3 goes into 4 once entirely. And then whatever the leftover is what will be assigned to this value. So in here, if I were to print the remainder, and then let's do one other example, I'll say 10 remainder 3. What I would expect in both cases is for the remainder to be 1. If we look at this first case, 3 goes into 4 once with a leftover of 1, so 1 is the remainder. In this case, 3 goes into 10 3 times, and again the leftover is 1. So we should be able to print that out and get both back, which is 1, and we can see that's exactly what happens down here. We get 2 1s evaluating. Now another kind of operator that I want to introduce you to just here is called the equality. Now the equality says, is one thing equal to another? And in this case, we found out that both this and this evaluate to 1. So if I wanted to check if those two outputs were equal, I would just throw in a double equal sign. The single equal sign means that we're assigning a value to a variable. The double equal sign says, okay, this is totally different. This is maths. We're checking an equality. Are these two things exactly the same? So where just a second ago, that printed 1 and 1 for both those two operators, now I would expect it to print, is this equal to that? Well, we confirm that it's true, so that should output true. So now if I run that again, we can see we do in fact output true down below. So the equality operator is super helpful, and it's one that we will also come across quite a lot. I'll just make a note here, checks if the left is equal to the right. And in this case, it could just be x equal to y. This would be false because x is 3 and y is 4, and therefore not equal. Now the next concept we're going to learn is the not keyword. Now, the not keyword in Python exists in a couple of different manners. First, just up here, we have the equality check. What we could do is check for inequality. So I could say x is not equal to y. And suddenly, this would evaluate to true. This would be true because x is not equal to y. So that little exclamation represents the not keyword. However, it could also be literally the not keyword. So in here, what I could also do is say if not number of eggs equal to 4. Now if I come onto this line, I could say print the number of eggs is not equal to 4. And this is a great example of how Python is kind of like English a little bit. It makes sense to humans. If someone were to read this, they would just think that my English is shocking. They would say if not number of eggs equal to 4. So that obviously means that they don't want me to do something if the number of eggs is equal to 4. So I could have technically done this syntax right here and just use the inequality check, but the not keyword is also a viable way of checking if something is not true. You just throw it in front of the condition and it's going to check for the inverse. So in this case, if I were to print this line, would this condition be true? Well, let's think about it. The number of eggs is currently equal to 5. So if not number of eggs is equal to 4, well, is the number of eggs equal to 4? No. So if not, no, that double inverses it to a true. So we would expect this to print. And if I run that, we do in fact confirm that the number of eggs is not equal to 4. Now, one thing I'm going to introduce you to here is what's known as a template string. Now in Python, sometimes we like to, inject variable values into our strings. So what I could do here, this sentence alone tells us a little bit about the number of eggs, that it's not currently equal to 4. But what if I actually wanted to print out the value? Well, I could do that by literally printing out the number. However, if I go ahead and save that and rerun my file, we can see that it just gives us this weird string right here that says not equal to 4.5. That doesn't really make a whole lot of sense. And so we introduce what's known as a template string. So that just means that it's going to be templated for a slightly prettier output. So what I could do in here is I could say is not equal to 4, comma, but instead use the colon, then have a space. And now, if I were to print this, at least that sentence makes a bit more sense. The number of eggs is not equal to 4, but instead 5. So we're a little bit closer to having a nicely outputted string, but we can take it one step further. What I can do is format the string by throwing an F in front of it. We put an F in front of this string, in front of the first quotation, and now what I can do is I can use the curly braces inside that string, and instead of having this on the end, I can actually inject the variable directly into the string, like so. So what this string is going to do is it's going to be formatted, and we're going to inject the number of eggs, the value associated with this variable, into this string. And if I print this, save and re-execute the file, we can see that the output is exactly the same. But we've just done it in a slightly cooler way, which is super handy. And so formatting strings is incredibly useful. It's a great thing to know how to do. So that was just a little bit of extra trivia, and it's also a good example of how this not keyword works. Now with that done, we're pretty much through a lot of the conditional logic, and it's time for us to jump into something very exciting, which is loops. Now there's two types of loops inside of most programming languages. One is known as the while loop, and the other is known as the for loop. Now a while loop pretty much just reads, while this condition is true, keep running this loop. And any logic that is scoped to that loop will be continuously re-executed. For example, if we refer back to my little project where I wanted to get all of these words, I had to go through, I think it was approximately 14,000 unique words, check them all to see how advanced they were. And that's not a process you want to do as a human, but a programming language can re-execute that same logic on 14,000 words, 14,000 different times really quickly. Now we're going to start off with the while loop, and it's pretty straightforward. We just use the reserved keyword while, And in here, we could say, let's have a variable called I. Now inside programming languages, I, J, and K are all the most common labels to use for variables when we're counting a value. But to make this more obvious, what I'm going to do is literally define a variable called count, while count is less than number of eggs. Now while clauses also finish in the colon, and they're pretty equivalent in their structure to an if block, where when we go into the next line, we have a singular tab indentation. I think it's approximately 4 spaces. And any code we write in here is scoped to this while block and only exists while this condition is true. Now currently our code is unhappy because we don't have a variable called count. So I'm trying to call or refer to a variable called count right here, and Python's telling me that, well, I don't even know what that is. So what I'm just going to do up here is say count is equal to 0. So now I've created a variable and I've assigned the value or numeric value of 0 to this variable. And now, currently, I've got this while block that is going to execute while count is less than number of eggs. So let's go ahead and print hello world, our very first print statement. Now if I go ahead and run this code file, let's think about what's going to happen. Well, we're going to encounter this variable. We're going to see that count is in fact equal to 0. And then while count is less than number of eggs, which is currently true, we're going to infinitely print out this hello world. Let's go ahead and run it. So I'm going to re-execute this command, and we can see it is just printing out hello world faster than my computer can process. And I now have an infinite loop, which is going to be super destructive, and I have to kill the file. Now the way that we do that is with the Control and C key at the same time. So I just hit the Control and C, we can see it just there, and it as quickly as possible terminated the execution of this file. And now I have my terminal back and we're no longer in an infinite loop. But I can scroll up here and I could just scroll forever because we could have potentially printed out 1,000,000 of these hello world statements in that length of time. So suddenly you can see how quickly it might have been for me to process 14,000 words. Now because infinite loops in code are not very good, what we would typically do is ensure that we generally progress towards an outcome that breaks the condition. Now one way we could do that is literally by using the break keyword. If we're in a while block and we hit the break keyword, we will exit out of the loop. So if I go ahead and run this code, we're going to enter this block because this condition is true. We'll print out this first line, then we'll encounter the break keyword, and that's going to break us out of the loop. So if I go ahead and run that file, we see that hello world prints a singular time. But what I could actually do is I could instead say count is equal to the previous value of count plus 1. So what this line is going to do is it's going to take the previous value of count, add 1 to it, take that new value, that new sum, and set it equal to count. And so if we think about how this loop is going to progress, it's going to, every time we run an iteration, the value of count is going to increment by 1 until eventually this condition is no longer true. So if I go ahead and remove this break line, I would now expect this to print out, well, how many times do we have to increment count before we break this condition? Well, number of eggs is equal to 5, count has to be less than 5, so I think that we're going to have to add on 5 values or 5 iterations to break this loop. So let's go ahead and run that. And just here, we can see that we did in fact have to rerun that loop 5 times, incrementally increment the value of count 5 times, until this while condition was no longer true, and then we broke out of the loop. What I could also do is have a special condition in here that says if count is equal to, use the equality operator, if it was equal to 3, then I could break out. So now, what will we expect the output to be? Well, as much as we might never meet this condition because we'll meet this one first, when count is equal to 3, we break. So that means that we have to increment the value of count 3 times, which means I would expect us to only print hello world 3 times. So now if I go ahead and run that, we can see that we do in fact only print it out 3 times before this condition is evaluated to true. We run this code and this break keyword breaks us out of the loop. So while loops are incredibly powerful, the one thing to be considerate of is your condition, and make sure that with every iteration you are one step closer to breaking out of the loop, otherwise you'll have an infinite loop. I could just as equally increment this by 2, and now what's going to happen is if I rerun this, we still only print it 3 times, but that's actually not because of this clause. If we're incrementing it by 2, it's going to go 0 to 2 to 4 to 6. When we're equal to 6, then we break the loop. We never actually encounter this condition because count is never going to be equal to 3. So this is just going to double how quickly we reach that break condition. So that's a bit about while loops. They are very fun. Now, in my opinion, the evolution of the while loop is the for loop. And so in most programming that I do, I'll almost never use the while loop, and it will by majority be the for loop. Now the syntax is similar. We use a for condition, except in here, instead of having, what is ultimately a Boolean condition, we provide a constraint. So for this many times, do X. Let's say, for example, I wanted to access my grocery list that I have up above, the shopping list. And let's say that I couldn't remember what it is, and I want to print out every entry in the grocery list. Well, what I could do is I could use a for loop for that. I could say, for every element in my list, in my shopping list, I want you to print it out to the console. And that's actually really easy. I could just say for X, where X is an undefined variable, inside of the shopping list. Now I could print X. And what this very simple block of code is going to do is it's going to go through every entry in the shopping list, and at each iteration assign that value to X, and then I can do whatever I want with it. So this logic right here, I would expect it to iterate over every entry in my list and print them out one at a time. And now if I go ahead and run this code, we can see that we get eggs, banana, milk, 4, and then my array printing to the console. There's 101 million different ways we can write for loops. We're going to write a lot of them in this course. This is just the most simple introduction. Once again, it works very similar to the if block and the while block, in so much that it has the scoped code. It's a single tab indentation across, and this print statement only exists within the realm of the for loop. As soon as we exit the for loop, we're done with the for loop. We've done for every amount of times that we were required to. This goes away and we break out of the loop and we move on down below. Now, one other cool way that we can write for loops is using what's called a range. And a range is brilliant because it works in the same way that a counting variable does. So what I could do is I could say for I, when we use counting variables, as I said above, up here we use the one count, a variable called count, for transparency's sake. But as we progress, when we have different counting loops, we'll typically use the variables I, j, and k to track how far through that loop we are, on what numeric iteration we are currently executing. So I'm going to have this variable I, and I'm going to say for I in, and I'm going to use a range keyword that's actually a function. Now this is a reserved keyword, and it works in a similar manner to the print statement, where once again we're going to learn all about functions later, and we call it or incite it or invoke it using these circular parentheses, and we provide an argument in here. Now let's say I wanted to count to 10. Well, what I could do is I could have a loop that ranges 10 elements. So what I could do is I could say range 10, and now if I were to print the value of I, what this is going to do is it's going to create an array. If you remember, that's like a list, and it's going to have all the values in the range of 0 through to 10. And now we're going to go for every value, every numeric value in that array that is created by this range 10. for a singular iteration, assign that to this variable I, and then print it out. So I is basically just, in this case, the placeholder for the current entry in that list. Now technically I could call this variable anything. It could be that. However, this is going to be a much harder variable name for us to work with. Anyway, if I were to go ahead and run this code, let's see what we get. We can see now that I just print 0 through 9. So the range is from 0 up to but not including the final value. Now what I could do to take this one step further is I could say for j in range, but what if I wanted to actually continue to go over the loop but also gain access to the current numeric index of each entry? Well, what I can do in here is I could first get the length of my array. And all I do is I set that equal to the shopping list. I'm trying to get the length of the shopping list, which refers to the number of elements in that array, the number of entries or values in that array, which I believe is these here. So there's 5 of them. What I can do is I can use another special reserved keyword called len. Now len is another function, and it is invoked with the circular parentheses, and we pass in the argument, which is the array or list, that we want it to count how many entries are contained within it. So this should evaluate to 5. And now what I could do is I could pass in that value into my for loop, and that is going to create an array that is 5 in length. And now what we could do in here is I could say current index is equal to j, and I could also say current value is equal to, I can go to the shopping list, and if you remember, lists all have a numeric index associated with them that starts from 0. And the way that we access the value at any index is by using these square parentheses, like we did with the dictionary when we looked up the name key, and we just pass in that index, which in this case is going to be j. Now technically the index could be j, or it could be current index, because they are equal. We've set current index to be equal to j. I'm going to stick with j, and then what I could do at the end of this is print, and I could have a formatted string, so that's going to be an f in front of the quotation marks, and in here I could say the current index is, use the colon, use the curly braces to inject a variable in there. I want to throw in the current index, and then I'm going to carry on this string and say, and the value at that index in the list slash array is, and I'm going to inject a second value, which is going to be the current value. And now we actually have a very powerful array. We've got the length of the array. We've created a for condition that goes over every entry in that array. It doesn't go further than that array. For example, if we only had 5 entries, it doesn't get to the 7th index and look up the 7th index, because this for loop is set up to only go for the length of the shopping list. We get the index of the current iteration, we get the value at that index, and then we print them both. And so if I go ahead and run this code one last time, we can see that we print out these really cool formatted strings where we can see that the current index is 0. Since our loop starts off at 0 and it works up to the value that is equal to the length of the array, which is 5, we start off at 0, and then we access the value at the 0th index, which is the eggs, and then we print them both. Then we complete an iteration. J goes up to the next value, which is 1. We print out that the current index is 1 because that's what this range does. It creates an array, and then we get the value at that index, which is bananas. And that's once again just an example of how brilliant these for loops can be. Now I know that might have been a little bit confusing, but bear with me. Once again, as we put this all to practice in chapter 2, it will all start to fall into place. So with for loops done for the minute, it's now time to jump into functions. And that's going to wrap up chapter 1, and with that all complete, we can then dive into chapter 2, which is our super exciting project. So if you're unfamiliar with the concept of a function, essentially the way I like to think about it is it's code or instructions that are on call. So we define what we want the set of instructions to do, but we don't actually execute it right now. And what this means is that later, when we are in a place to now execute or invoke this function, we can call on that body of logic that we have defined at an earlier stage, and we could even execute that body of logic 1,000 times. Write it once, run it a whole lot. And there's a whole paradigm known as functional programming, where essentially almost everything you do in a code base can be broken down into one objective, and you can create a function for that specific objective, and it means that you end up writing this real nice code because everything is broken down, it's compartmentalized into different, utilities. And so we're going to learn a little bit about functions, which, as I said earlier, we predefine how the function works, and then at a later date we invoke the function, or we call on it to come and do its task. Now the first thing to know about functions is that they need a name. Now that's how we refer to them. And we saw some examples of functions earlier. I think we've seen two. We've seen the print function, so that's its name. And we've also seen the len function, which finds the length of an array or the number of entries in an array. Now defining functions in Python is very easy. We start off with the def keyword, def for define. And it kind of works in the same way that a variable does, where a variable is a label and the value associated with the variable is a data type. And a function is technically also a data type. It's a type of data, and the name of the function is kind of like the variable. The syntax to create it is a little bit different, so that's why we're starting off with this def declaration. But I could create a very simple function here that just says print underscore funny underscore word. Now the first thing to know about function names is that once again they can't have spaces, and they pretty much follow all the same rules that variables do. After we've defined the name of the function, we then have the circular braces. Now up above, where we call the print function, we have the circular braces at the end, and this process right here is invoking the function. So behind the scenes, Python has already defined this print function for us to take advantage of. But the circular braces are for arguments, and we're going to learn all about them in a second. And then to finish the creation of the function, we just need the semicolon. Then we enter on a new line, and everything in here is tabbed across because it's scoped to this function. So in here I could just print, and the word I want to print is Gilgamesh. That's going to be our funny word. So this code here, these two lines, is our first function. We've defined a function. Now just writing this code does not invoke the function. As I said earlier, defining a function doesn't mean that you're executing the function, you're just defining the code base that you want to be able to call on at a later stage. So the complement to this process would be like, let's say it's 20 minutes later, or I'm 100 lines down in my code base. I would then invoke my function, I would call on it by name, and use these circular parentheses to complete the invocation. And then what would happen is our code base would go, oh, we're looking for this function. It would look back to where it was defined, and then it would execute the logic or code scoped to that particular function. So that's super cool, a little bit of fun. Now let's take a look at these circular parentheses. What therefore is arguments? But what is an argument? Well, an argument in a human context is obviously we have an argument, we make points. But in a programming language, it's more like context. So what context or information does this function need access to be able to execute correctly? So in here, what I could do is I could, let's say print funny word takes an argument that is the funny word. So I'm going to define an argument just here. And what this is doing, this is where we're defining the function, and I'm letting it know that it should expect an argument. When we print, this string in here is the argument. And the print function that's defined by Python knows that it's expecting arguments that it then needs to print out down below. So when we define the function, we need to let it know, okay, we're going to give you some context when we go and actually invoke you. Now in this case, what I could do is comma separate the funny word and then print out the funny word. And at the end of this, I could throw in an ampersand. So it looks like we're printing out Gilgamesh and the funny word. Now, currently, where I've actually invoked the function, I'm not giving it any arguments. So then when I go and execute this line, it's going to look for the arguments that I told it needs to expect, and it's going to be like, well, the user didn't give us anything, so this is going to be none. This is going to be an empty value. And we could go ahead and test that, run our file, and we can see that print funny word is actually missing a positional argument. So essentially what that means is that we've gone to call this function and we didn't provide any inputs, and Python has said, well, I'm not going to do that because that doesn't make any sense to me. So instead, what I could do in here is pass in a string as an argument, and I could just say, let me think of a funny word, Doug. Sorry if your name is Doug. You're going to be the example of a funny word. I think it's a brilliant name. I want a dog, specifically a corgi. You probably met Doug at the intro of this video. That's my dream. So we're going to have Doug as the funny word. So now that I am passing in this argument, the function expects to receive this argument, this context, this information, or an input. And the string here is going to be assigned to this variable name, and then within the scope of the function, we're going to refer to it by that variable name or that argument name. So now if I go ahead and run that file, we can see that it does work appropriately, and I can see that Gilgamesh prints, but so does Doug, which is the keyword I just provided down here. Now you can have loads of different lines in here. You could have 6 different print statements. You can define, 101 million different functions. But typically, for best practice functional programming, one operation or one utility per function is best. And one thing I like to get into the practice of, especially as your code base gets bigger, is explaining what my functions do. This is for me, and this is for anyone else who is looking at my code base. So obviously, I could leave a code comment just up here and explain that this function takes an argument and prints out the word provided as an argument in addition to the word Gilgamesh. That's what the function does. And that's a helpful practice to get into, because as, once again, your functions become more convoluted, if someone's trying to understand your code base, that can just help them disentangle everything and figure out what's going on. One other cool syntax that we can learn about is the triple quotation. So it's 3 singular quotations to start and 3 singular quotations to end. And this is a special type of string that can be entered onto different lines, and anything in here is a string. So the other way that you could leave a code comment is you could actually just create this special string in here, and I could copy all of this text, paste it in the middle, remove that comment, and that would also be a valid way of describing this function. We've created a string here, we haven't assigned it to a variable, we're not doing anything with it, but Python's happy with it, and if someone is reading through our code base, it will help them understand what the function does. So that's another way that you could leave a comment if you prefer green text or whatever text is associated for strings in your VS Code theme. So that's a little bit about functions. Now, one last thing I want to introduce about functions before we move on and jump into chapter 2 is what is known as the return keyword. Now, currently, when we invoke this function, it's just going to get to the end of it, and then we'll move on. We're done. And that's super cool. I could say for k in range 3, so I want to loop over this 3 times, and I could now print the funny word 3 times and tab that across. And now I would expect to print out this code 3 times. And so what's happening here is we have this loop. We create a range 3, that's going to be a range from 0, 1, 2, up to but not including 3. Each of those values is going to be assigned to k, one after another, and so we're going to have 3 iterations and consequently 3 print statements. Each loop is only going to finish when we run off the end of this code. We finish the function and then we jump into the next iteration and we do that again. But back to the return keyword. The return keyword is super special because similar to how a break keyword breaks out of a while loop or a for loop, the return keyword, the reserved keyword, exits out of the function. So now we can see that the code down here is kind of grayed out, and that's because my code editor recognizes that any code beneath the return is futile. It's not even going to be reached because we're just going to exit out of the function and carry on. So if I save this file and rerun it, we can see now that we don't print out any Dougs or Gilgameshes because we will have technically executed this function 3 times, but we returned out of the function before we actually got to the print statement. Now that's not all that return does. Return has, some extra special features and functionalities. So what I'm going to do down here is define a new function, def, and that's going to be called multiply_2_numbers. Then we have the circular braces because it needs to expect some arguments, context, or inputs. And then we have the colon to end the definition, and then we can jump into the scoped block of code. Now, I lie, we're actually going to have 2 inputs in this case. One is going to be input 1, and we're going to comma separate the arguments. Then we're going to have input 2. And you could name these whatever you want. It could be number 1, number 2. And what I'm going to do in here is return out of the function immediately. Now this function right here is going to multiply 2 numbers, but what I actually want it to do is give me back the answer. And when I say I want it to give me back the answer, I don't want it to just print it. I want it to actually return something from this function. When I finish executing this code, I want to leave something in the place of the multiplication that is the product of the 2 numbers. So what I could do is I could return input 1 times by input 2. We're going to multiply those 2 variables. So now let's go ahead and invoke this function. Multiply 2 numbers, we call the function, we invoke it using these circular parentheses, and I'm going to pass in an 8 and a 9 because I feel like that's a multiplication that everyone seems to get wrong. So now, or is it, actually I think it's 8 times 7 is the one that everyone gets wrong. 8 times, let me know in the comments down below which one you find harder, 8 times 7 or 8 times 9. Anyway, we are going to multiply these 2 numbers. So this is going to invoke the function and it's going to return these 2 numbers. Now let's go ahead and run this code and see what happens. So I've just gone and executed the code, and we can see that nothing outputs down here, even though I've invoked the function. So what has actually happened? Well, essentially what has happened is we have returned out the multiplication of these 2 numbers, and it's now sitting where this line of code used to be. It takes the place of this invocation. So if the value is 56, you can just imagine we have 56 sitting right here, but it's not doing anything. I might as well just write 56 down below, and it's just not doing anything, even though it's technically Happy Python. But typically, what I would do is I would have a variable called product, and that would be equal to 56. Or that could be equal to 8 times 7. Or it could instead be equal to, could copy this line, throw it in front. And now I could say that the product, a variable called product, labeled product, is equal to, and I can assign the output or what is returned from this function. And so now this return keyword is going to spit out the multiplication of those 2 numbers, and it's going to assign it to this variable. So then what I could do beneath is print product. And now if I run this code once more, we can see that 56 was in fact assigned to this variable. It was left behind in place of where we initially invoked the function. It was returned back. It was assigned to the variable, and then I could print out the value associated with that variable. And now I have a super cool function where in future, if I found it too hard to use this little asterisk key, I could instead write out the whole long function name. Now I'm not saying this is a good example of a function. These are just to demonstrate how functions work and the different features and functionalities of the functions. But in the project in chapter 2, we will have some ever so slightly more complicated functions, and we'll put all of these concepts to good use. And so with functions done for our introduction to Python, there is but one concept left that we need to be familiar with to complete the project in chapter 2. And the last concept we need to learn before we move on is what's known as a class. Now, a class is a reserved keyword inside of Python. We have it just here, and it works in a similar way to, we have this def declaration for a function, while we have a class declaration for a class. Now in programming, earlier I talked about functional programming, the paradigm of functional programming. Well, there's another paradigm called object-oriented programming, which is all about objects. And objects, if you recall, are the dictionaries that we learned about earlier, where a dictionary just has a key, a lookup key, and an associated value, a word and an associated definition, and our object is right here. And it had two key value pairs. One was age, that was the key, the lookup key, age, and the associated value of 28, and then we have the name and the associated value of James. And this line is commented out, so currently to Python, this person dictionary only has one key value pair inside it. Now, objects are so awesome. There's so much you can do with them. You can see how descriptive they could be. You could have a user, you could have a whole lot of data, you could have anything inside of an object. And they're also very performant, which means that it's incredibly quick to manipulate an object or look up values inside of an object, key value pairs inside of an object. And what a class is it's like an extension of an object, where imagine you're playing a video game, and imagine you have a user, your character. And just like I have my person up here, just imagine that your character has like the health, it has the speed, it has the attack power, it has all of the inventory items, it has a history of where you've been, locations you've discovered, and once again, maybe a million other parameters that need to be kept track of to understand what's going on with your character. And imagine trying to write out this object for, 100 different characters. It's going to be super painful. So what a class allows us to do is define a template for an object. So for example, let's say I wanted to have a class called person. Where person just above, we kind of looked at how we could have an object that describes a person, but this is just one object that I made to describe me. What if I have loads of people to describe? Well, that's why we create a class. We can have a template that I can then just create an object from that template, and it's already filled out with a lot of the core parameters that are required to describe that object. So here, we're defining the class, and the name is person, and classes are always capitalized, so the first letter is a capital. The class keyword just here is the declaration, and then what we have is no arguments, no circular parentheses, just the colon. Now inside of this scoped block of code is one tab across. This is where we define all of the parameters, all of the keys, all of the properties of this object or this class. Now before I actually go and define any of the parameters in here, one thing I want to point out is that inside of an object up here, I could have a key that's called action, and that could actually be a function. So what I'm going to do just up here is define a function called jello, def jello, just like that, and let's say that just prints the word jello. What I could do is I could assign jello to the action. So just here, this function is now, assigned as a value. It's a valid data type, so it can be assigned as the action. So then when I call on the person and consequently the action associated with the person, it prints out jello. Now that's a bit of a complex way to create this code block, but the reason I'm doing that is because we can also have functions or actions as part of the properties of a person. So in here I could define jello 2 underscore 2. That takes some arguments, then we have the colon, and in here I could print jello space jello. And now what I could do is instantiate this class. So the way that we instantiate a new class is literally by saying new underscore person is equal to, and I call the class, I instantiate a new instance of this class, and then I have the circular parentheses. And now what's going to happen is that this new person is going to look up the template for this person object, and it's going to create that object. It's going to create a new instance of it and assign it to my new person. So down here I could print new person, and we could go ahead and run this code base, and we can see that it is a person object. Now I realize at this point this is a slightly confusing concept, but don't worry, once again we will cover it again in chapter 2, and you'll have an opportunity to get your hands dirty with it and really start to understand how it works. But at the end of the day, the class is literally just a template for creating objects, where now every time I want to create a new person, and I don't want to have to assign this Jello2 function to them because they all need it, I can just use a class, and I can just instantiate a new instance of that class, which creates an object that's fully fledged with all of the properties needed. Now what I could also do is, instead of just printing out this, I could actually call Jello2 as a property. So I could say .jello2, and since that's a function, although technically when a function is defined within a class it's referred to as a method, so this is now a method, which is just a function, and I can invoke the method, and now when I don't even need to print that because that's a print itself, so I can remove these print statements, and now I'm going to go within the new person. I know that because I'm using this template, it's already going to have access to this core action, this function, and then I can invoke it. And now if I save that code and run that once more, that gave me an error. Now this is a really interesting error, and we're actually going to take a look at it and see if we can understand what's going on. It's given us a type error, and it said Jello2 takes 0 positional arguments but was given 1. So what this means is that Jello2 takes 0 positional arguments. So that means that when I've defined it, I've told it not to expect any positional arguments. But it says that it was given 1. Now in this case, just here, it doesn't look like I've given it an argument. This is blank. So what's going on? Well, this is one of the core distinctions between functions and methods. When we define this method within a class, it always has one default argument, and that is known as the self. Now the self can be a bit confusing, but it always needs to be provided as the first argument. You can have a bunch of arguments afterwards, that's absolutely fine, but it always needs to be there on any functions defined within a class. And the self refers to the original entity. So in this case, self is going to refer to the new person object because that's where I've instantiated it. And essentially what it does is it allows me to refer back to the instantiated version even from within the template. So this is the template. So when I talk about the self, that's not referring to this generic class. The self only comes alive when I instantiate it. And so now inside of this person, I've instantiated this class, it's created this fully fledged object. When I call this method, it's going to automatically refer to the self. And that's something I could do a whole lot of stuff with, as we'll see very shortly. But the moral of the story is that the self refers to that instantiation, that specific object. So it's kind of like an entity almost. You could think of it as being an actual person, and it refers to that specific person. So that's kind of fun. Now the biggest problem that this person doesn't have currently is we've obviously seen how we can define an action, but it has no properties, no parameters. So what we could do, let's say down here I want to be able to instantiate a new person and provide some arguments. Let's give them a name, it's going to be Doug, and let's give it an age which is 28. Now in this case, I've provided 2 arguments, but I haven't told my class to expect any arguments. And unfortunately, classes work a bit different from a function, so I can't just, have some circular braces just here and tell it to expect an input. But let's just see what's going to happen when I do actually give it some inputs, but I don't necessarily define how it should handle them. Let's go ahead and run this code. So now I run this code, and it's telling me that person 2 takes no arguments. Just as we kind of expected, we're giving it arguments, but we're not telling it how it should handle them. Now when you define a class, the way that you get it to handle inputs is you define a new function called underscore underscore init underscore underscore. And this is also a function, so it does need, or technically a method, so it does need these circular braces. And I'm just going to enter it onto a new line. And in here, as I said earlier, methods always need to expect the self. But after that, I can receive arguments. And one of them is going to be the name, and the other is going to be the age. And then we have the colon. And just in here, what I'm going to do is refer to the self, which is the instantiated instance. And I'm actually going to create a property which uses the dot notation. So if we're thinking of as an object, I'm going to say dot name and set that equal to the name. And I'm going to do the same with the age. I'm going to say self.age is equal to the age. Now this syntax right here is equivalent to when we referred to the object above. Let's look at when we tried to read the values from the object. Just here, we had the person object and we read the name key. There's two ways we can do that. That is one syntax. The other syntax that we can use is called the dot syntax, and it works exactly the same. So we take an object. The self becomes an object when we instantiate it. It's a template for an object. When we instantiate it, it becomes this object. And then the self is that object, and the name is a key. So just here, I've used the same dot notation. I've accessed the Jello2 key within the person object. And I can do the exact same thing. The self is essentially just the same as the new person. I can access the name key, and I can assign a value to it equal to the name. And I can do the same thing with the age. And so now that I've defined the init function or method and said that it can expect these extra 2 arguments, I think that should fix my code. So let's go ahead and run that once more. And now I don't get any errors. And that's because we have set up our class to expect inputs or arguments. And these can be assigned to that instance or that object, which is going to be our new person in this case. And so we're going to create a new person entity. It's going to be an object. It's going to have these 2 parameters. It's going to have this particular action assigned to it. And that's going to be our new person. So I can call this action Jello2, and we get the Jello output. I could then print out new person dot name, and let's see what happens. I'm using that new dot syntax that we learned about earlier, and now we can see that Doug outputs just as if it were an object. So that is super cool. And once again, I know that is confusing. It's a lot of information to be presented with, but that's the point of chapter 2, and we'll really start to consolidate all of the information in your brain, which will be excellent. But the last thing I want to demonstrate, just to wrap this up, is that I could have a new person, and that could be equal to my person class, and I could instantiate it, and this could be Lucy, and she could be 42. And now I've just taken advantage of that template object instead of having to create a new object every single time, so it's super convenient. And I could have loads of different classes, and we're going to see how we can take advantage of classes in our chapter 2 project, which is time to dive into. Anyway, wrapping that up, well done on persisting throughout chapter 1, but chapter 2 is really where the magic is going to happen, so that's going to be super exciting. And with that all said, let's get started. Alright, we have now finished chapter 1. Time to dive into our very excellent project in chapter 2 and put all of the lessons learned from chapter 1 to good use. Now what I'm going to do is start off by closing all of our files, and we're now going to create a second file that's called new file, and that's going to be chapter_2.py. Now we're actually going to need 2 files for this chapter. One is our chapter_2.py, and the other one is going to be called play.py. Now, the first thing we're going to do, and this is something I like to do whenever I embark upon a bigger project, is we're going to comment out all the different steps that we have to follow to complete this project, in addition to describing what the project is actually going to be. And we're going to do this using code comments inside of our chapter_2.py. Now, first up, we're going to have, we're going to answer the question, what is the project? And I'm going to create the code comment using the pound at the start. And then underneath, we're going to answer the question with another code comment. And the project we're building is a vocab builder / language learning app that uses spaced repetition to learn and practice new words. So that's the app we're going to be building. Now underneath that, I'm going to have a new section, and this one's going to be called instructions. And these are going to be some step-by-step instructions that we need to follow to go from having this definitions.json file, which is literally just a dictionary. JSON, if you're unfamiliar, is like, it's a dictionary, but it's turned into a string. And so for all intents and purposes, it's a dictionary with some slightly stricter formatting rules, specifically that every key and associated value has to be wrapped inside of double quotations. And so here we just have a whole lot of different words and their associated definitions that we want to learn. Now you need to download this file, and it is available inside the GitHub repo for this project, which is linked in the description down below. If you head over to the GitHub repo, be sure to hit the star button. I love that support. And just download this file or create your own definitions.json file and copy the content across would be equally valid. So we're trying to go from all of these words and associated definitions to an application that's going to test us on these words at ever increasing intervals. An example would be, let's say I had to learn the word lugubrious, which I know is one of them, and also demure, which is a super trendy word at the moment. What it would do, this app, is it's going to introduce us to lugubrious, then it's going to introduce us to demure, and then if it's time to review this word, it's going to test us on lugubrious. And essentially how the app is going to be played is we're going to first create this really long list of words that uses an algorithm to space out every single word we want to learn using spaced repetition. And then when we go and play it, we're just going to go through that list and see how many words we can get through without making a mistake. Or essentially the gap between encounters for a particular word is going to increase every time we successfully answer it. And that's how spaced repetition works. You encounter a word, you answer it correctly, and every time you do that, you then push it out even further into the distance, and you take a longer amount of time until you next have to challenge yourself with that word. And the ultimate goal is to eventually, have an indefinite period of time where it could be 10 years until you next visit the word and you're like, I remember what that is. So as for the instructions, let's have a look. We're going to start off at step 1.0, where we have to go from this definitions.json and we have to turn it into this list. So step 1 is to take definitions.json, read it in as our data, and use a spaced repetition algorithm to create a long list where each word is encountered less and less often, thus increasing the spacing between encounters as we strengthen our knowledge of the word. So that's step 1. Then step 2, once we have the list, is to create a game where a user has to get through as many items in the list, i.e. answer them correctly, and when they ultimately fail, then they get a high score and have to start again, which also forces them to continue practicing. So that's the 2 steps that we're going to have to follow, and consequently these are basically the 2 files. So all of the logic for this step is going to go inside of chapter_2.py, and the logic for creating the game is going to go inside of play.py. Now these are obviously the overarching steps. There's a whole lot of sub-steps that we have to take within each of these major steps. For example, at the end of this one, we need to produce this list and we need to save it as a file that can then be read in this step. And that's going to mean that we have a hard copy of this list so that it never has to change. We can continue using the same list over and over again, and we don't have to continually reproduce a new list every time, which would kind of defeat the purpose of the game. So if we now break down these steps even further, let's say 1.1, step 1 is to read in the definitions file and process it. Underneath that, let's say we read in this data. We have step 1.2, we've got this JSON file. Now what we need to do is create a class, well actually I'm going to call it a complex object that keeps track of a whole lot of properties about the word or attributes. Now this step is kind of like the person example we encountered in chapter 1. And some examples of attributes that have to be associated with the word, not only is there the definition, but we need to keep track of information such as when we last encountered it, what the current spacing should be, how many times have we reviewed it, is it a new word? If so, we have to define the word. And so there's a bunch of parameters, and so what we're going to do is to create this complex object, we need to define a class for this object. And even further within the step, I'm going to go 1.2.1, we're going to need to define a bunch of methods, which if you recall, are just functions specific to a class that are kind of like actions, such as a method that we can use to automatically handle a word encounter. Then once we've defined this class, so this is 1.3, we can instantiate this class object for every word. And then underneath that, once we have this, now we can really get down to business, which is 1.4. We can create the spaced repetition algorithm that we'll use to create this long list that cleverly introduces new words and tests old words at the appropriate intervals to follow the rules of a spaced repetition algorithm. So I don't need that last bit. At appropriate intervals. And then once we have this algorithm, the last step is to save this long list of all our words to a CSV file that can then or later be read by our game. So that's going to be all the steps that we need to complete this file. And I already have the code here. It's going to end up being about 115 lines of code, which at the end of the day isn't actually that much. But it's going to be such a brilliant opportunity to practice and develop upon everything we've learned inside of Chapter 1. Now, creating the game is also a bit of fun, and that is about half as long of a file. And in here, I'm actually just going to add, I know I like how it is. So we're going to say step 2.1 is to create the files to read both the long list of spaced words, of spaced repeated words, I guess, so that we can loop over them and test the user continuously until they fail, at which point we give them a score. And also the word definitions so that we may show a user a word definition if it's their first time encountering the word. So that's a pretty long step, but ultimately it's just to create the two functions that we need. And this was originally files, I changed it to functions. We need to create two functions to just read in our long list of words and all of our definitions. After that, we need to define a continuous while loop that tests the user on each word in the list, one after another in the provided order, and will only exit when each word has been mastered or the user makes a mistake. And then the last step is to, I need to number this step, so this is 2.2, and then the last step is to 2.3, print the new high score when they fail or win, and also a command to start again. Now, one of the other reasons I like creating these word instructions on how I'm going to complete these files is because not only does it help me compartmentalize the project in my head, but it's also a really good way to break down your project into all the different functions that you'll need to successfully execute upon the project. So that should be super cool. And then as I'm working through it, what I can do is just under each of them, I can now enter down and I can start writing out all the steps in here. So that's going to be super fun. And now that we have all the steps, how about we actually get started with some Python code and dive into our chapter 2 file first. Now, new concept introduction, imports. Python obviously has a lot of predefined functions that we can leverage off, such as print. We learned all about print in the first chapter. Well, it gets even better than that. Python also has a bunch of libraries that we can take advantage of that have predefined functionalities or utilities. And in this case, we're going to need 2. And the way that we can go about adding them to our project is by using the import key and then the name of the package. So just here, I've imported a package called JSON. Now this package is going to be important in this project because we have a JSON file that we're going to need to interact with on our hard drive. So we're going to need this library to allow our Python code to go and read this file. Now the second library we're going to need to import is CSV. Now CSV is pretty equivalent. It's just a predefined library that gives us a whole lot of means and methods of interacting with CSV files. Currently we don't have a CSV file, but that's the purpose of this particular Python file, is that we're going to read in the JSON and we're going to create a list of all the words spread out according to our spaced repetition algorithm, and then we're going to save it to a CSV file that we can then read inside of our other Python file, which is our game. So these are 2 Python libraries that we're going to need to import. Now if we come down just in here, we're going to need to start off by creating a function that reads in our definitions.json. And that's going to be actually this first step right here, because this one is actually just the overarching description of this project. And so what I'm going to do is actually just remove these 2 lines and this one, and I'm going to spread them into their respective files. So that's the description of this file right here. I'll move it up the very top so that's the the highest level of precedence. All of our steps are underneath, and then what I'm going to do is copy all of the step 2s into our play.py, just like that, because that's where all of that code is going to go. So that's pretty cool. Once again, if you're wondering about some of the key shortcuts that I'm using to make my code jump around, I've linked a website in the description down below that runs through all of them. It'll help you become a super quick coder. So now we've got our steps, we can dive into number 1, which is to read in the definitions file and process it. So for this, we're going to start off by defining a function, and we do that using the def keyword, and then we're going to say load underscore vocab underscore from underscore JSON. Now I like making my function names super descriptive so that it's very apparent to anyone looking at them what they actually do. After the name, we obviously need the circular parentheses and then the colon. Now this particular function does need an argument, and that argument is going to be the file path. And so how it's going to work is we're going to, when we need it, call this function, pass in a file path. That could be anything. In this case, it's going to be definitions.json. And then inside the function, we're going to tab across, have our scoped code, and this is going to process that file once we've read it in. So what I'm going to do up the top is use the triple single quotation, and we're going to leave one of these comments that describes the purpose or intent of this function. And so it is very simply going to load vocab data from a JSON file. Now underneath that, we're going to introduce you to a new syntax, which is the with keyword. Now this is a reserved keyword, and it's typically used for loading in different files. And what we're going to do is then use another keyword called open. Now open is a predefined Python function just here, and we actually get a bit of information about it. And we just open the file path. And then we provide a secondary argument, which is the mode, and we're just going to say open in read mode. This little R stands for read. So the way that this open is going to work is we're going to invoke it with a circular parentheses, and then we're going to pass in the file path, which is received as an input to this function. And then the second argument, we're going to comma separate them and use the R key to read them. And then we're going to finish off by using the as keyword and then a variable name, which is f, and a colon at the end. Now this is a new line of code, and essentially what it's doing is it's actually kind of just speaking to us in English. We can say, with this file open to read as f, labeled as f, what are you going to do with it? And after the semicolon, we can tab down and we get some more scoped code. So we tab across from this indentation just here. And inside here, we can now define a variable called data and set that equal to, we can call on the JSON library and we can load in this file. Now load is a method specific to this JSON file. We can take advantage of it. And this f just here is us opening this file to read, assigning it to this variable f, and then we're processing that JSON so that it becomes an object that we can then interact with. The last thing we need to do in this file is return something out of it. And for now, I'm just going to return data, which is created just here. Now this actually isn't finished, so what I'm going to do is leave a comment, and that just says, come back and finish this later. Now the reason I'm not finishing this line just yet is because we actually need to, once we have all of this JSON data as an object, all of these definitions, we need to process all of these words through our vocab word class that we spoke about before. But just to quickly explain what this return data does, eventually when we do have the class that we can use to read all of these words and convert them into this class object that has all these special parameters, we can then return that out of this function and give it back to whoever it was or wherever it was that we invoked this function. So that's our first little function complete. That's super neat. On to task 2, we now need to create this complex object, which is the class, that keeps track of a whole lot of properties. Now, if you recall, the object template is the class. To create a template for an object that has a whole lot of special properties, we use a class. It's like a predefined structure. And so we use the class declaration or keyword, and after that we create the name for this class, and it's always capitalized, and it's going to be the vocab card. Now in here, I'm not using the underscore to separate the two words. I'm instead capitalizing every new word. And then at the end of the vocab card, we just use the semicolon. Now inside here, I'm going to use this triple quotation again so that I can provide some information about what this class does, where it essentially just represents a single vocab word or card. I'm calling it a card because it just has slightly more properties than a word standalone. And inside this vocab card, obviously it's going to receive a whole lot of arguments, so we're going to need to define that init method, but it's also going to have two other actions available within it. So inside here, what I'm going to do is define the first method. So we say def, it's kind of like a function. And if you recall from earlier, the first def is the underscore underscore init underscore underscore. Then we have the circular braces for the arguments. And in here for now, we're just going to have the self, but there's a whole lot more later. And then we have the semicolon. Now underneath that, for the second, I'm just going to return out of this function, because if I don't have that return line, my Python is going to be unhappy until I do actually have some code scoped to this function. So that's just going to sit there as a placeholder for the minute. Now the second action that we're going to need associated with every word is the ability for it to update itself. So let's say we encounter a card, for example. I want it to have an action associated with that object that allows it to update, saying, okay, the person got it complete. Let's change when it needs to be next visited. Let's change the interval between repetitions. Or potentially, if we're encountering it for the first time, let's make sure we update that so that next time we encounter the word, we don't show the definition for it. So the second action I'm going to create is a function or method called update card. And that's also going to receive the self as the argument, and we're just going to return out of it. Now the last method I'm going to have associated with each vocab word is a method called def is_learned. And that's also going to receive the self as the argument and have the colon at the end, and we're just going to return out of that. Now typically when you're trying to define a state of something, for example, whether or not a card or a vocab word is learned, using the is keyword in the function name can actually provide a lot of information about what's going on. For example, just here, this kind of makes almost sense in English. Vocab card is learned. Well, we can imagine that the outcome of this method is going to tell us whether or not we've learned this card. So it's just a cool way of creating very explicit function names that are also super short and concise. And so now that we have a little bit of information about this vocab card, what we're going to do just up here is come and finish off our very first function. And so underneath data, what I'm going to do is create a new line just in here, and we're going to create a variable called result, and that's going to be equal to an empty dictionary. Now in chapter 1, we saw how we can create a dictionary. Well, in this chapter, we're going to see how we can write information to the dictionary and continue to update it. So I'm going to start off with this blank dictionary and assign it to a variable called result. Now in here, what I'm going to do is use a for loop. So I'm going to create a comment, use a for loop to loop over every word and instantiate a new instance of the class for that word and add it to the dictionary. And so in this case, we're going to end up with a dictionary that's full of key value pairs, where the key might be the name of the word and the value is the vocab card object that keeps track of all of the information about that word, all of the properties, the actions that we will need. Now I'm actually going to put result underneath that comment because this is kind of the action in here. And so now that we have this dictionary, we're now going to create the for loop using the for keyword. And I want to do this action for every word in the dictionary. So the way that we're going to do that is by going to data. So we're going to say for every entry in data, but I'm going to use a special Python method called items. And so what this .items does is it says for every item in data, where an item represents the word and the associated value. So I'm basically saying for every word and associated value inside of data, which is our JSON file, and what I'm going to do is just in here assign them to the word variable and the definition variable. And I'm going to say for word and associated definition in data, and I'm going to access all of the items, which is all of the key value pairs. And so now inside of this for loop, I will one after another go through every word and associated definition, and I can add them to my result dictionary. So in here, what I'm going to do is I'm going to say result, access the dictionary, and I'm going to use these square parentheses to create a new index in that dictionary, where the key or the label for that entry is going to be the word. And I'm going to set that particular entry equal to, and I'm going to instantiate a new instance of the vocab card, which, if you recall, just creates a single vocab card. And in here, we can pass in some input parameters. So this is just going to be our glorified vocab card object. And in here, it's just going to take the word and the definition. So now, for every word and definition key value pair inside of our JSON dictionary, we're going to slowly, one after another, build up this result dictionary. And at the end, we're actually going to return result. So when we've created this massive dictionary that contains all of these vocab cards, where each vocab card is the value associated with the word key, we can then return that out of this function. And that's going to allow us to create this huge conglomerate of information later when we're finally ready to actually load in the data. Now just here, we're passing in two parameters when we instantiate this vocab card, but we haven't actually set up vocab card class to expect these parameters. Now if you recall, the way that we do that in a class is inside of this init method, where init is just short for initialization. So when we initialize an instance of this vocab class, or instantiate an instance, all of the arguments that we provide are going to be passed into this init function after the self argument. So in here, it looks like we're passing in a word and a definition. And so we can just tell it to expect a word and comma separate a definition. And those are our next two arguments. Now, when we actually create this vocab card, it actually has a few other arguments and parameters that we need to set. But before we do that, I'm also just going to quickly come into each of these methods and once again use the triple single quotation to describe what each of them does. So this method defines the arguments or properties expected when we create an instance of this class i.ea vocab card. I'm also just going to throw it in for the update card. So I'm going to do the triple quotation, and this method is responsible for handling an encounter with the vocab, with the word, I guess, and updating when we should encounter it next, and a few other things. And this last one is very simply for telling us if this word is learned completely, which is based off a max repetitions parameter that we will define later. So it's just good to have these little descriptions inside these methods so that anyone reading the code can understand exactly what they're for. Now, when we create this vocab card, I'm going to remove this return because we don't need to return out of it. But what I am going to do is manipulate the self. Now, if you remember, when we instantiate this vocab card, we take the class and we instantiate it to create this vocab card object. Now, in a minute, we're going to print them all out so we can actually see what it looks like. But at the end of the day, it's just going to be an object, where an object just has key value pairs, just like this definitions.json has a whole lot of key value pairs. And at the end of the day, JSON is fairly equivalent to an object. So the self is the object. And in here, what we're going to do is set these input parameters as keys in that object. So what I'm going to do is I'm going to say self.word, where the self is the object, and .word means to access the .word key. Whether or not that exists, it doesn't matter, because in this case, I'm assigning a value to that key, which is going to create the key value pair. So in here, I'm just going to assign word, which is the input argument just here, and that's going to be set to this key, which is a property of the dictionary, the vocab card object or dictionary. Now, it's actually kind of funny in this particular case, when we create this result dictionary up here, and we have all of these word keys, where each key is associated with a vocab card, that's quite literally creating a dictionary, because we're going to have a dictionary or an object where we look up all of the words, we look up by the name of the word, and we find a whole lot of information, including the definition associated with the word. So it's quite coincidental or almost serendipitous that we are quite literally creating a dictionary. But just a reminder that the word dictionary and object are interchangeable, just as the words list and array are also pretty interchangeable. So we've done that with the word. We also want to manipulate the definition parameter of the self and set the input definition equal to the key or associated with the key definition, and I should spell that correctly. So this line right here is going to create the key within the self object, and that key is going to be definition, and assign the input definition to that particular key. Now the vocab card is actually also going to have a bunch of other parameters. So if I were to write them all out, we're going to have a self.repetitions, which is going to track the number of times we have encountered a particular word. We're also going to have a self.interval, which is going to be the interval or the minimum number of times we have to encounter different words until we are allowed to revisit this one. And it's also going to have a self.ease factor. Now this is a parameter that you could fiddle with, but essentially it defines how easy this word has been historically. And we're also going to have a self.review counter. Now where the interval basically determines, all right, how far out should we push this word until we next revisit it, the review counter determines if we've reached that interval and consequently the word is ready for review. And finally we're going to have a self.isNew parameter or key, and that's going to determine whether or not we've encountered this word before, because if we haven't seen this word before, then we need to display the definition so that the first time a user encounters a new word, we give them the definition and they can get some practice writing it out, and then in future we obviously don't show the definition because we're going to test them on it. Now where do all of these values come from? Well, we're not going to pass them in as inputs every single time. But what we can do is we can still let this method expect some inputs, but instead of providing them when we instantiate the class, we can give them default values in the case where if we don't provide them, they can just assume a default. Now when you do this inside of a method or a function, assigning a default value to an input name, for example, just in here, I could have repetitions. I can now set that equal to 0. So what this is going to do is, I could technically pass in a repetitions value up here, 4 repetitions. And 4 would now be assigned to this input name for the scope of this method. However, if I didn't provide 4, repetitions would just automatically assume the value of 0. Now, when you're defining arguments like this with a default value, they always have to come after the arguments or inputs that you can guarantee will be provided. So in this case, word and definition will always be provided. So they have to come first, and then the optional ones can be second, and we're going to give them all default values. So repetitions is going to assume the value of 0, and we can assign repetitions to the key repetitions within the self object. And we're going to do this with all of these. So after that, we're going to have the interval, which is going to default to 1. So when we first encounter a word, we want to then encounter another word, and then we immediately want to revisit it. The definition is going to be fresh in their head, and they need to try it out real soon and get some practice with it, and only then can we start to push the word further out into the distance. We're also going to need an ease factor, which is equal to 2.5. Now the ease factor is kind of like an opportunity for advancement if you wanted to take this project to the next level after the course. And it's basically a placeholder for some adjustments that you could make. We're just going to set it to a default of 2.5. But an example of where this could come in handy, the way our game is going to work is it's going to kill the game if someone makes a mistake and make them restart. But you could also build a game that instead of killing it, adjust an ease factor for that word depending on whether or not they got it right or wrong. And if they got it wrong, you could just make sure that they revisit it again shortly instead of ending the game. So that's just an option. We're going to have it here. We're not necessarily going to use it, but it's something that you could fiddle with in future. After that, we're going to have a review underscore count, and that's going to be equal to 0. Because when we first encounter a word or create a word, we haven't reviewed it, or we haven't reviewed any words. So the counter or number of words reviewed is going to be 0. And then finally, we have the is new parameter, and that's going to be equal to a Boolean value of true. And that's because every word when we first encounter it is default true until otherwise set to false, which is going to be one of the actions of the update card. So now down here, I can set the interval key within the self object equal to the interval input or argument. I can do the same for the ease factor. I can do the same for the review counter. And I can do the same for the is new. And so now when we instantiate a vocab card for every word in the data, every vocab card or every word is going to be associated with an object that contains all of this information in addition to all of these actions about it. So that's going to be super handy. And this is kind of, an analogy would be creating a new player in a new game where they have all of these default parameters, the health, the attack power. They have some default attacks and what they do and how they manipulate the data about the individual. And then you might create that entity 1,000 times, while instead we're just doing the same thing for a vocab card or a word. So now that we've completed this init method, we've basically allowed the successful creation or instantiation of all of these vocab cards. What I'm actually going to do now is print out results so that we can take a look at what it actually looks like. And I find this a really helpful exercise because sometimes when you're writing all of this code and it should theoretically do all of these things, it's hard to really imagine what that looks like. We've said it's a vocab card, but what does that actually look like? We've said we've created this dictionary just here, but what does that actually look like? And the way that we're going to do that is by printing it to our console, which is where we can view everything. Now, the way that we're going to do this, obviously just here we've created a function, and functions are for on-call logic. Don't run it now, only run it when we encounter the invocation in this file. And so what I would do is I would take this function name, and down the bottom of our code, after we've defined all of the functions we need to run this file, then what I can do is I can invoke them in the appropriate order, and I can pass in a file path, which in this case is going to be definitions.json. Now, if I went ahead and ran this file, it would go ahead and, create all of this logic, create these functions, create the class, and then upon the invocation line, it would then look back, see what the function does, and run all the logic in the function, all the logic scope to the function. Now, we established earlier that the function returns a result. So that means that the result is left behind in the place of this invocation. So what I would need to do is assign it to a variable, and I'm going to call that vocab underscore cards and set that equal to, I'm going to load all of the vocab from the JSON. I'm going to provide the file path as the argument, which is then going to be assigned to this argument right here, this input name. And then we open up the file path, we read it, we assign it to a variable f, we load all of the JSON, we assign it to the data, and then we process the data, creating a vocab card for every word inside of the definitions. So that's how this logic is going to work. Now, just before we run this file, I'm going to make one last adjustment in here. And this is like a best practice for when you're creating Python files. And it's a kind of specific line. It's a bit random, but we're just going to write it out together and then I'll explain what it does. So what we're going to do in here is create an if block. And for the condition for this if block, where basically we only run all of the scoped code if the condition is true, is we're going to say if underscore underscore name underscore underscore is equal to, so we're going to use the equality operator, which is the double equal sign, see if the left hand side is in fact equal to the right hand side, And the right hand side is going to be a string that says underscore underscore main underscore underscore. At the end, we're going to have the colon, and then what I'm going to do is tab this line so that it is scoped to this if block. Now what this code does is it ensures that we are running this file directly. So for example, when I write the command python3 and specify specifically this file name, when we run that command, this parameter is automatically assigned to be underscore main. Now the case where that wouldn't be true is if we were running this file through another file. So let's say we had some code in here that was being used in a separate file, and that works the same as these imports right here. We could have some code written in this file that we then import into another file. Well, if we ended up running code in here through another file, then this name parameter would actually be updated to match the name of the file, and consequently would not be underscore underscore main underscore underscore, in which case we wouldn't want to run this logic. Now I know that is a lot to wrap your head around, but the moral of the story is that this line just confirms that we are in fact running this file directly and not indirectly. If we were running it indirectly, this name would not be main, and therefore we wouldn't invoke any of this logic. So it's kind of just a protective clause. It's a best practice in Python, and how it works is we define all of the logic we're going to use above, and then inside of here, that's where we kick everything off. We start invoking it as we need it, and we make all the magic happen. And now that we have the vocab cards, what I'm going to do is print the vocab cards, and then we can inspect and see exactly what it looks like. So let's go ahead and run this file. I'm going to say python3, and I'm going to specify chapter underscore 2.py. And we can do that because we're inside the Python beginner course folder directory, and that file is a direct child of that folder. So let's go ahead and hit enter and see what we get. Well, the first thing that's wrong is we get an issue, and I believe that's because I spelt definitions.py incorrectly, and it looks like I'm missing an I just in here, so I copied the file name and pasted it in directly. And now let's run that once more. I'm going to use the up arrow to find the previous instruction, and I'm going to hit enter. And now in here, what we can see is we have a dictionary. I know it doesn't look very obvious, but if we closely inspect what we have, here we can see all of the keys. And just here we have the key. It's a string in the word, and that's associated with a vocab card object. We have another one, the comma separated key value pairs. Here's the key. We have the colon, and then we have the value. This is a key value pair. We comma separate it from the next key value pair, and this collectively becomes our dictionary object. And what I could actually do is I could access a particular word within vocab cards, and if you recall, the way that we do that is we use the square parentheses, and I'm going to look up the string keyed, and now what it should do is I should print out this vocab cards dictionary, but the value specifically associated with the keyed key within that dictionary. So let's go ahead and run that again and see what we get. And so now that I look that up, we see that the value is this vocab card object. And what I could then do, we know that that's an object, and that object contains these parameters. So I could then access the .definition key. And this is an example where I'm going to use the other syntax to access a key within a dictionary. And now if I run that once more, we get the same thing, and that's because I forgot to save the file. Let's do that again. And now I get back the definition of the word keyed, which is to make cold or to sharpen. So that's kind of fun. And I recognize that can be a tiny bit confusing, but as we continue to do it, it will start to become more apparent and obvious as to how it works. And what I could also do, just to demonstrate this again, is I could modify this isLearned function, where now we have a return keyword. Let's just say in here I want to add a print statement that says, not sure yet because I haven't finished the logic for it. Let's say that's the isLearned action. Now what I could do is within that vocab card, I could actually access that method and I could invoke it, because the method is kind of like a function. We predefine the logic and we call it or invoke it later. And now if I were to run this again, that's going to print out not sure yet, because I haven't finished the logic for it. Now the interesting thing just here is that we got this print out none underneath, and that's because the code in here, this ends up printing a line. This code alone is going to call this method, which ends up printing this line just here, this print statement, but it doesn't return anything. And so we're trying to print a print statement, but because this isLearn doesn't leave anything in its place, it just executes something down here. Eventually that vanishes, and then when we try to execute this this parent print, we end up printing nothing, because nothing is left in the place of this once it's finished executing. Anyway, none of that is actually important, but what we are going to do is change this line to print starting vocab learning session. So the way that our code is actually going to work is we're going to read in this vocab, and then we can start running all the crazy logic. So the next thing I'm going to do is finish off this class, these two methods specifically, and then we can get to our algorithms. So next up on our list is the update card. Now this method is all about how we handle an encounter with a word. And what we're going to do in here is use some if-else logic. So how it's going to work is I'm going to say if, and I'm going to check the self object, and I'm going to see what the current repetitions is. Now the repetitions defines how many times we've encountered this word before, and thus what the spacing should be in future. And so what I'm going to do is first check if it's equal to 0, which means that we've never seen this word before. And then I'm going to have a colon, and so just here, this is our condition, where we check the repetitions key of the self object, and we use the equality operator, and we see if it's equal to 0. And if it is, then what I'm going to do is I'm going to change the intervals key of the self, and I'm going to set it equal to 2. I'm going to assign the value of 2. I'm going to use the assignment operator, not the equality operator. And I'm going to assign the value of 2 to the interval key of the self object. Now what this means is that if we've never encountered this word before, we're going to run a whole lot of logic, which means that we're going to print out some information, test them, but then eventually after we've done that, we need to update the card. And what that's going to do is it's going to say, okay, so we've just encountered the card. Now we want to change the interval so it's a bit bigger, because the interval is by default 1. Now let's space out and make it a slightly bigger interval. Now underneath that, we're going to finish with that scoped code, and we're going to have another if clause. We're going to say if self.repetitions is equal to 1, then we're going to say self.interval is equal to 4. Now what this line does, let's say we run this first check and we find that self.repetitions is actually 1, which means that it's not equal to 0. This code, it won't get run, it'll get ignored. So after that, what we're going to do is check if it is equal to 1, and now this one's going to be true, and that means that we need to update the interval from what it was earlier to now instead be 4. So we're going to push that word even further out. And then underneath that, we're going to say else, which is the else condition, which will run in the case that neither of these is true. And we're just going to say self.interval is equal to, and we're going to use some special math functions available in Python, specifically the round. And we're going to say self.interval multiplied by self.ease factor. So if the interval last time we did it was 4, then we're going to multiply it by 2.5, and now it's going to become 10. And then if it was 10 and we multiply it by 2.5, it's going to become 25. And so you can see how that is going to continually push out the number of intervals until we see that word again. Now when we have two if blocks like this, where they can't coincide, it's only going to be one or the other, what we can do is we can actually chain this middle step in between by using what's known as the else if. And that's the new command, it's elif. And essentially how this works is we say if this first condition is true, if it is, run this code, else if the second condition is true, run this code, and if neither of these two are true, then run this final command. And that's just going to give us some super clean code to increase the interval for every time we encounter this word. Now that's not all the updates we need to make for this card. We also need to increase the repetitions every time we find it, every time we encounter it. And the way that we're going to do that is by accessing the self.repetitions key, and we're going to set it equal to what it currently is, and then we're going to add 1 onto it. Now there's actually a better syntax for this. If we're trying to take the old value and increment it by 1, and then assign that new value to the key, override it essentially, what we can actually do is just say self.repetitions plus equal 1. And this is a sneaky little syntax that's just a bit tidier. And it basically just says increase this value by 1, take the old value plus 1 on it, and assign that to the key. So I'm just going to do that instead as a shorthand. And I'm going to comment this line out and just say C upgrade below. So that's going to handle the repetitions. After that, what we're going to do is just say self.isNew and going to set that equal to false. Because this update card is for an encounter, so if we've encountered a word, then the isNew parameter, which by default is true, if you remember up here, we have isNew is equal to true. Well now, it's going to be equal to false, and that will always be false in future. And then after that, what we're going to do is slightly adjust the ease factor. We're going to say self.ease factor is equal to, and we're going to say max. Now what max does is it takes 2 arguments and it chooses the maximum one and uses that. So we're going to take a maximum of value of 1.3, and these numbers are just, standard for a space repetition algorithm. And then for the second argument, we're going to take the current self.ease factor, so ease underscore factor, and that is meant to be a comma, not a period in there. That's a comma. And then we're going to take the current self.ease factor and we're going to plus 0.1 onto it. So that's just going to take the 2 of them. And this is some code that will actually not be relevant to us, because in all cases, the ease factor is going to win every single time. The ease factor is never going to be 1.3 because the default is 2.5. But essentially, every single time it's just going to slightly increase the ease factor with every encounter. This would be more relevant if you did in fact manipulate the ease factor as we discussed earlier. But that's just a good line for us to have, and I'm going to leave a comment here that just says increment ease factor slightly. And then the last thing we're going to do is change the review counter. And up above, let's just quickly define what the review counter does. When this reaches 0, the word is due for review. So essentially what we're doing is we're now setting the review counter equal to the interval, which is how long it should be until we encounter this word. How many other words should we test first before we need to revisit this word? And then with every word that we successfully answer, we can decrement the review counter until it's equal to 0, and then we can review the word. So we start off setting it equal to the interval, and then we count down till 0. The word is now ready for review, and then we can test the user on it. And so that is the method that is going to define our interaction with each word. Now the last one just here is learned, and this one is also relatively straightforward. I'm going to remove this print, and it's actually the easiest one of all of them. And is learned is actually going to return something out of it. So you'll notice that the init doesn't return anything, and that's because it doesn't need to give anything back. It's just updating values associated with the word. The update doesn't give anything back. It's just once again updating the values or keys associated with this vocab card. The is learned actually needs to output true or false, so it does need to return something. And all we're going to do is check self.repetitions, and we're going to see if it's greater than or equal to max_repetitions. Now, max repetitions is actually going to be an argument of this method, so I'm going to comma separate it and pass it in just here. And I'm going to make it an optional argument by providing a default value of 5, which just means that if we've encountered a word 5 times, we should be pretty cool with it and we can move on and focus on other words. So as long as we have encountered a word 5 times, then what this is going to do is it's going to see if the number of times we've encountered it is in fact greater than or equal to 5. If it is, return true, and then the vocab card is learned true. Cool. So now that we've completed the vocab card, it's time to jump into the algorithm for producing our long list of words. But just before we do that, I want to make one distinction regarding the object and the class. Up until now, I've been saying that the class is a template for an object. And that is true. We can see just here when we instantiate these classes, these vocab card classes, we can see that they do in fact become an object. However, there is one distinction between defining an object. For example, I could have my object and set that equal to and use the curly braces. This is the dictionary or object. And in here I could have a key value pair where the key is going to be name and the value is going to be James. And the key is a string, the value is a string, and the semicolon separates the key and the value in this key value pair. Now if I wanted to print out the value or change it or modify it, then what I would have to do is I could either print out the entire object, my object, or if I wanted to print out the name or the value associated with a particular key, then as we've seen earlier, I use the square braces and I provide inside the square braces the key. Now in this case, I'm using a string as a key. You could technically use a number in Python. That's not necessarily something you could do in every language. But the point is that we use the square brackets and then we provide the key inside, and that looks up that key inside the dictionary or the object and returns the value associated with that key. Now we've also seen how when we're using a class system, we instead have all of these dots and we don't use the square brackets. And that's for a very good reason. And so as much as technically a class creates an object, it just creates an object with a slightly different set of constraints. And so when we're trying to access keys within this class object, we instead use the dot syntax, whether that's for accessing the method or a particular key that's associated with the self. This method is essentially a key inside this self object, as much as, the key definition, which is associated with the actual definition instead of a function, where it would be with the method, for example. So the moral of the story is that as much as both of them become objects, when we create an object via a class, we just have a slightly different syntax for accessing values associated with keys, whether or not that's a traditional value like a string that holds the definition, or it's a method, which is just another attribute or property of that class object, where an example of that would be what we did earlier, where we accessed the .isLearned method. But yeah, just to summarize, when the object is instantiated via a class, we use this dot notation, but when we use a traditional object, we instead use the square brackets notation. And that's just an important distinction to be aware of. Anyway, we've done with the card, and we've also completed the logic that reads in our definitions.json and gives us this dictionary that contains all of these vocab cards, where each vocab card is associated with a key, which is the actual word. And that's what we printed out down here. And so now that we have all of our data loaded, we can run this algorithm to produce this long list of words where they are sequenced according to the space repetition algorithm. So we're going to need to define a bunch of methods. Okay, we've completed that. So that actually lets both of these steps just here can actually go just up here. They're kind of all in this space. So now the next step is 1.4. We can create the space repetition algorithm. So let's hit enter here and start writing our code underneath this step. Now the first thing we're going to need for this step is an accessory function. So what we're going to do is write def to instantiate or to create our function, declare our function. And this function is going to be called show word status, and then it takes these circular braces to input any arguments, and the arguments is going to be the vocab underscore cards, and then we have the colon, and then we have our scoped code. Now in here we're going to use the triple singular quotation, and we're going to provide a description of what this function does, and we're just going to say it displays the current status of the words and also returns, which means it spits out the due words, which is a list. Now this function is something that you could fiddle around with, but what you could do in here is just throw in a whole lot of print statements that could explain where you are in the space repetition algorithm, what the progress of it is. In this case, that's actually something I'm going to leave up to you, but how you would do that is just add a print, and you would print some simple statistics based off the vocab cards. What I'm going to do instead is create a variable called due words, because that's the secondary function. We need to return out of this function all of the due words, where we call this function the show word status, and we expect it to get the status of all the words and consequently return to us what words are up for review. So in this case, due words is going to be equal to, and for now we're going to have an empty array. So underneath due words, what we're actually going to do is then return due words. So that's going to spit out due words from this function when we invoke it, and it's going to receive the, and then obviously in between these two steps, after we've created the array, we now need to actually figure out what words are due. Now we're going to do that with a for loop, where we're going to loop over every vocab card inside of our data that we have loaded, this result right here, which is actually also down here. So these are the vocab cards, this is our data that gets passed into this function, and then we're going to go over every vocab card and figure out which ones are up for review, and consequently put them in the due words, and then we can test the user. So what we're going to do is say for every card in vocab cards, which is the argument or the input that this function expects, and we're going to use a .values method. After the .values we have the semicolon, and then in here we can have our scoped code. Now essentially how this is doing is it's when we use the .values, instead of giving us back the key value pair, for example in this for loop, above we use the .items. So when we have some data and we use the .items method, what that does is that gives us access to the word, which is the key, and the definition, which is the value. Well, in this case, we just need access to the vocab card, which is the value. And so instead of using the .items method as much as we could, we're just going to use the .values, and that's going to assign each value one at a time to this parameter card, and then we can look at that particular vocab card for that particular word, process it, see if it's ready to be due, and then move on to the next one. So in here what I'm going to do is write a comment, and it's going to say one by one check the vocab card class assigned to each word and see if it's due for review, and if so, add it to our array/list of due words. Now the way this is going to work is we're going to use an if check. We're going to say if, and then we're going to provide some logic that is going to check if the card is in fact ready for review, and that is going to be two conditions. The first condition is that the card, so we're accessing the card, which is the vocab card. Remember, if we scroll up, all the values are these vocab cards, and they get assigned to this parameter card, and so we can check for the field review counter. Now if we come up and see what the review counter does, when this reaches 0, the word is due for review, and we know that this review counter key is in fact a parameter of that object. So we can access the .review counter key, see what that value is, and more importantly, check if it's less than or equal to 0. because as soon as it reaches 0, it's due for review, and if it keeps going even lower, then we really need to get around adding it to our list. Now the one caveat to that is that we don't want any cards that are new. And the reason is because these are due words. And due words is going to be different to new words. So due words is specifically for checking for words that we've encountered before to see if they're due, it's time for them to be reviewed. We don't want to throw every single word at the user from day dot. We want to gradually introduce them, making sure that we take time to review the ones that are due. So what we're also going to do is we're going to say if the card.reviewCounter is less than 0 or less than or equal to 0, then it's due for review. But we also want to make sure we want to say and not card.is_new and then colon. So what the second half of this condition does is first we have this AND condition, which we learned about in the chapter 1. It's part of the Boolean conditional operators. We have the AND and OR. When we have the AND, that means that both the left-hand side and the right-hand side have to evaluate to true. And so in this case, we've already talked about the left-hand side, when that's true and when it's not. For the right-hand side, we just have very simply, we check not card is new, which means that the card is not new. Basically, we've seen it before. So if we've seen the card before and it's ready for review, then let's add it to our list, and we're going to put that logic inside the scope of this if block. We're going to say in here, due words dot append, and that's going to be a method that we invoke. We call it using the circular parentheses, and in here we pass in the card. Now, dot append is what's known as an array method. Arrays are lists, and they have special methods that are for adding things to the list. For example, we have .append, which just means throw the new entry on the end of the list, and whatever we pass in as the argument is going to get pushed, it's going to get stuffed onto the bottom of that list into that array, and then we're going to do that for every card in our vocab cards. We're going to check them all, see if they're due, and we're going to return the ones that are due and filter out all the rest. And so that's our little handy helper function that we will need to figure out what words are due for review. Now underneath this function, we're going to have another one, and this is where the magic is really going to happen. And this one's going to be def, and it's going to be called review_session. Now then we have the circular braces where we define the function, and in here we're going to have a couple of arguments, and then we're going to have this colon at the end. Now the arguments or inputs needed for this function is going to be all of our vocab cards, and we're also going to need a parameter called max_repetitions. Now this is going to be a default parameter, so I'm going to set it equal to 5, which means I don't have to pass it in as an input every time I invoke the review sessions function. Now what this is going to do, we're going to enter that on a new line, tab across, because this is going to be some code scoped to this function. And we're once again going to use the triple single quotation, or the 6 of them. And in the middle, we're going to say reviews words until all are ordered/mastered. So we're going to one by one create this long list of words that are sequenced according to the space repetition algorithm, and that's just going to go until all of them are technically ordered or mastered. Now the other thing we're going to need in here is a parameter called history. And history is going to be equal to an empty array, and essentially how this function is going to work is we're going to follow this algorithm, see what word is up next, and then we're going to add it to our history, and that's going to be our final list. And so we're gradually going to follow this algorithm, find what word should be next, add it to the history, and create this long sequence of words that follows the space repetition algorithm. So we can add a comment just here that describes what this does. It tracks the order of words reviewed or introduced. Now underneath here, what we're also going to do is have a parameter called total words reviewed, and that's going to start off equal to 0, and we're going to increment that as we go forward, and that's just going to be a fun statistic that we can keep track of as we review all the words. Now as for the actual logic, what I'm going to do, once again it's a slightly complex function, so I'm going to take some time to break it down into a bunch of steps. What we're going to do at the very end of this is create a comment, and we're going to write out our history list to a CSV file. So that's going to be the last step. Before that, we have to actually have the algorithm. Now the algorithm, so in here I'm going to say write spaced repetition algorithm. Now in this case, we need to repeat an action a whole lot of times, so we're going to need a loop. Now when we're choosing between for or while loops, typically a for loop is when you know for how many times you want to complete this iteration. In this particular case, we know the number of words that we have, but we don't know how long this end list is going to be necessarily. So we're going to use a while loop and break out of it when we're ready to finish. So what we can do is we can start off by writing while and then use the true keyword and then have a colon. So this code alone technically creates an infinite loop because while true is always going to be true. And there's nothing we can do about it. So as soon as we enter this block of code, it's going to run until we either kill the code execution or we encounter the break keyword, which we'll need to do. So once we're in here, we now have a block of code that we can run over and over and over again, and this is where we're going to create our spaced repetition algorithm. And in here what we're going to do is we're going to write out some comments that describes each of the steps we need to take within each iteration of the loop. So first up, what we need to do is, if we're just starting this iteration, then we need to reduce the review counter for every single word. So the first thing is to reduce the review counter for all words. Now a singular iteration of this while loop is essentially good for one word. So every time we complete an iteration, we then need to count down the review counter for every single word, because we've just answered one, which means that every word is one step closer to being up for review. So first step is to go through every single word, decrement that so that we know if it's now ready after answering the previous word. Now that all the counters have been reduced, the second step is to get the words due for review. And because this is actually a really easy step, we're going to do it together right now. We're just going to say due underscore words. That's going to be the variable name. And we're going to assign to it using the assignment operator. And we're going to invoke our function show word status, which, if you recall, returns out the due words and takes the vocab cards as an argument. We're going to invoke it with the circular parentheses, and we're going to pass in our vocab cards. So this is going to call on that function, that predefined body of logic. We're going to pass in the vocab cards as an argument, and that is going to spit out all of the due words, which we can then assign to this variable. Now in some cases, for example the very first iteration, we're not going to have any words for review because we're at step 1. We haven't even encountered any words yet. So what we're going to do is have some backup logic that says if no due words, introduce a new word as a filler. Now how the spaced repetition algorithm works is basically we slowly add new words and then we're tracking how often we encounter them. And so let's say we're at a point where we're learning 10 words. You know, we've been introduced to 10 words. Well, there's a chance when we go and check if they're ready for review that none of these words are actually ready for review yet. So in the meantime, what we can instead do is introduce a new word. So the priority for the algorithm is always to review words that are available for review, and then we use the opportunities where there are no words for review to introduce a new word. And that's just going to stop our algorithm from overwhelming a user from too many words from day one. And we're going to prioritize learning words that we've already been introduced to above learning new ones. We'll obviously eventually get through all of them, but we just don't want the due words to get forgotten about because that's not going to be good for our memory. Better to focus on learning 5 words and gradually introducing new ones than throwing, 1,000 words at a user and just them not being able to recall any of them. So if there's no due words, introduce a new word as a filler. And then the last step just here is to review the due words. Now obviously just here we can see that these comments and steps are scoped to this while block, and this one is scoped to the review session function. And currently we've only done one line, so why don't we start from the top and work our way down. So we're going to start off first by reducing the review counter for all words. So in here, what I'm going to do is say for card in vocab cards dot values, and I'm going to invoke the values method and then have a colon at the end. Now this line should be pretty familiar because we literally did it just up here, and I said what it essentially does is it goes through every key value pair, it specifically looks up that vocab card value, and it assigns it to this variable card, and one at a time we can check the card to see if it's good to go. Now, instead of checking each card to see if it's good to go, which is important for creating the do words, what we can also do is for one card at a time, we can modify them one at a time and make sure that each one has the review counter reduced by 1 for every single word. So we're going to do that one at a time. So let's say we start off with card 1, and I'm just going to say if card.review underscore counter is greater than 0, and then have a colon at the end, because there's no point in counting down the review counter if it's already 0. And inside of this scoped if block, I'm just going to say card.review counter underscore counter minus equal 1. Now this little block of code is scoped to this if block, which is scoped to this for loop. And how it works is one by one, it goes over every vocab card class, it checks the value of the review counter, and if it is higher than 0, then it needs to be counted down because we're one step closer to encountering that card. And so this logic just here, if you recall, we actually encountered a similar version, where essentially this logic just is a decrement by 1. And it takes the current value, and where earlier we had a system that added 1, it takes the current value and adds 1 to it and updates it. This version just counts it down by 1. So it takes the current review counter and subtracts 1 from it. So that reduces, it goes over every single card in our vocab cards and reduces the review counter for all words. Now we've also got all the words ready for review. So now let's handle the case where there's no due words. So in here, what we're going to do is say if not due underscore words. Now, due words is an array, but what the not does is it turns it into a Boolean value, and Python's pretty clever. And let's say due words was completely empty. Well, Python is smart enough to understand that as kind of being like false. It's basically saying, well, there's no due words. It's smart enough to check that and convert it into a true or false. Is this true? Do we have due words or not? And if not due words basically just says, well, if we don't have any due words, then what we can do is create the filler word. So what we're going to do is define a variable called filler underscore word, and for now I'm going to set that equal to none. Currently we don't know what the filler word is, but it's time for us to find out. And then in here, what we're going to do is loop over every card and find an appropriate filler word. So we're going to say for card in vocab cards.values, same loop as before, go over every single vocab card, and we're going to have an if clause that says if card.is underscore new, we're going to check the is new key, and if it evaluates to true, then what we can do is we can say filler word is equal to the card, and then because we're using a for loop, well, we can break out of it at this point because we no longer need to continue. We've found a brand new word and we can introduce that word. So that's going to look for a new filler word that we haven't previously encountered, and we're going to do that by checking for the is new key, seeing if is new is true, which means it's a new word, and we can then set it equal to the filler word and use it. Now, there's a case where we potentially won't find a new filler keyword, But what we're going to do is just say if we do find a filler word, then we're going to have some logic in here. First up, we're going to say filler word dot is underscore new and set that equal to false. And that's a capital false, because obviously it's not new anymore, we're encountering it. And I'm just going to leave a comment here, and this is going to say mark as no longer new. Underneath that, you could actually add a print statement that just says introducing a new word, have a semicolon, and I could turn this into a formatted string by throwing the F in front of the string, and then I can use the squiggly parentheses, the curly parentheses, and just throw in the filler word dot word parameter or key. If you recall, within the vocab card is the entity, and we have to access the dot word key to get access to the word, just like we would access dot definition to access the definition. So down here, what I'm going to do is access the word key of this filler word entity, and that's going to be injected into the string, and we can print it out. Now underneath that, what I'm going to do is append this to the history array. That's our list. And because we're encountering this word, it consequently gets added to our array. So I'm going to append the filler word dot word. I'm not going to append the entire card. I'm just going to append the word. And then after that, what we're going to do is say total words reviewed, which is basically our count. We're going to plus equal 1. That's going to increment its value from 1. And then finally, well, we've just completed a word encounter, which means that we don't actually want to review any new words, because remember, this singular iteration is for one word encounter. So what we're going to do is use the continue key. Now the continue key is similar to the break key. They're both reserved keywords specific to loops. And this just says, instead of breaking out of the loop and running it no longer, this just says, okay, we're done with this iteration, move on to the next one. Now just before we jump on to the next step, which is going to be the continuation of this if block, there's two things I just want to point out. First and foremost, just here, is what this filler word is doing. When we look for the filler word, we look for a card or a vocab card that's new, that we haven't encountered before. And when we find that card, we assign it to this variable filler word. Now in future, when we modify filler word or we refer to filler word, that's actually modifying that original vocab card within vocab cards. So that's not just modifying an entity called filler word, that's actually referring back to the original one and making those modifications. So just here, when I say filler word.isNew, well, that's actually linking back to this card, which exists within filler cards, which is our original data. So that's modifying our original data. And that's just something to be aware of. This isn't like a duplicate copy of it. It's actually referring back to the original data. We're just assigning a particular card for this instance. We're giving it a new variable name so we don't have to look it up. We just have it assigned, or we can refer to it by this variable name. Now the second thing I just want to point out before we continue this loop is that, at some point throughout this course, you might be feeling as a new Python programmer that, well, I just really don't think that I would be able to create this code base from scratch. And I just want to point out that this is technically quite a complex project. I really like it for this course because I think that it demonstrates all of the concepts that we learned in chapter 1 and puts them into practice in a really cool example. However, objectively, the project and the code is relatively complex to put together. It took me a little while to prepare this code base. And I just want to point out that as a beginner, don't be too hard on yourself. If you don't feel like you could reproduce this in your head from scratch, these things come with time and practice. And the second thing, if you feel overwhelmed at the scale of the project, the best thing you can do, don't give up. You always want to give these things a shot, but it's about compartmentalizing it. And I think at the end of the day, being able to build a complex project is just about breaking it down into all of these key steps. And if you feel like a key step is still too complicated, then you really just need to break it down further and understand, okay, what are the parts of this? And for the most part, this always works because every complex project can ultimately just be broken down into a whole lot of very simple steps. So if you can learn the skill to break down these projects into the simple steps, then I'm sure as a beginner Python programmer, you'll be able to slowly work through them until you have this big project. But yeah, at the end of the day, it is a relatively complex project. As you move on from this, you'll always be able to refer back to this code base because it demonstrates everything we need to learn, all of the cool things you can do. And with practice, you'll be able to create projects infinitely more complex than this one, just because you have all the foundational skills and you know how to compartmentalize a project into a whole lot of simple steps that come together to create this complex outcome. Anyway, next step on our list. So now, let's say we find a filler word and we introduce the filler word. That's all well and good. However, what happens if there's no filler word? Well, that implies that there are no new words. And if there's no due words and there's no new words, then there's a chance, it's not 100%, but there's a chance that we have in fact mastered every word. And so what we're going to do in this case is just check and see if we are in fact ready to complete our loop and break out of it and save our words. So what I'm going to do here is have an else block, and this else block is going to be tied to the if block, so they're at the same indentation. If filler word, check the filler word. If there's no filler word, else. Let's see if we've finished and mastered all the words. Now what I'm going to do in here is define a parameter called all_learned and set that equal to true. And the way this code block is going to work is I'm going to assume they're all learned and then find evidence to the contrary. And then if we do in fact find evidence to the contrary that we haven't all learned them, then I'm just going to keep going. And the way that we're going to do that is something that we've done before. We're just once again going to say for card in vocab cards.values. We're going to go through the vocab cards object. We're going to look up all of the vocab card values, which is the actual vocab card entity. Then we're going to have a colon at the end. And in here, what we're going to do is we're going to say if not card.is _learned, we're going to call or invoke the isLearned method, which if you recall just up here, here we have it, isLearned, and it takes the max repetitions as an argument. And what it does is it checks that particular vocab card and it sees if we've done it, if we've repeatedly learned this card more than the suggested number of repetitions, which is the max repetitions. So we're going to invoke this isLearned method, and then we're going to throw the colon at the end for this if block, and this is going to say if not card is learned, so if we haven't learned the card, then we need to keep going. Now in here what I'm going to do is provide max repetitions as an argument. Let's actually spell that correctly. Max _ repetitions. Now it looks like I've spelt it incorrectly inside the original argument for this function, so let's just update that. Max _ repetitions. That's better. Fix those spelling errors. Now the max repetitions in this argument defaults to 5. We technically don't have to provide it as an argument because the method itself assumes 5 if it's unprovided. If it is provided, then it will use that 5 instead. But it's 5 either way, and we're just going to provide it as an argument down here. So if we find that the card is not learned to the maximum number of repetitions, that's 5, then what we're going to do is we're going to say all learned is equal to false. We found evidence to the contrary that we haven't learned all the cards. And we're going to break out of this particular loop right here. However, if we finish this loop, that means that we've checked every single card. And in checking every card, we confirm that they were all in fact all learned. Then what we're going to do is say if all learned is still true. So if we got through every card and we found that all of them were learned, we never set it to false. Then we're going to have a colon, and in here we're going to print out a string that says congrats, all exclamation mark, all words are learned, and then a little smiley face. Now in the case that we find all words are learned, we need to break out of our bigger loop. Now this break is going to be associated with the parent loop, or the next big loop. It's not scoped to this loop, so this break is not relevant to this loop just here. And it is in fact relevant only to our while loop right up here. So this little while loop, if we go through all this logic, if we've learned all the words and we don't have any due words, then we can break out of that while loop and we can now go and save this history list to the CSV file. So that's just going to handle that case. Now, the last step we have to finish inside of our algorithm is to review the due words. So this logic just here was for the filler words, and consequently that's only in the case that we have no due words. But if we do find due words, then we need to review them. Now how this is going to work, it's pretty straightforward. We're just going to say for card in due words, where due words is in fact a list of words that are due for review. Because once again, if we found that there was not due words, we would have instead executed this filler code block, which would have jumped us onto the next iteration, and that would prevent us from reviewing any due words in this iteration because we'd prioritized a new word. If we instead skip this code because we do have words for review, we don't need a filler word, then we're going to loop over every due word and test them all. And so we're going to say for card in due words, so that's going to say go over every card in due words, and now we're going to test them. So we're going to say print, and this is going to be a formatted string, so we're going to have an F in front of the string, and in here we're just going to say reviewing colon, and we're going to use the circular parentheses, and we're just going to pass in card.word. And this is just going to print out every word that the space algorithm has deemed necessary to review in this order. And then we're going to call on the history array, which is our history list, and we're going to append card.word. So card.word is going to go inside the circular parentheses, which is where we provide the argument. And then after that, we're going to call card.update underscore card. We're going to invoke that method. And I'm just going to add a comment after this line that says track the word in history. And then finally, we're just going to say total words reviewed plus equal to 1. Now, one thing to note about this particular case is that earlier I said this while block is for one iteration of a word. But that's technically not quite true. It's true if we're introducing a filler word. But then what happens is that if we find we have a whole lot of due words, then we're going to actually just finish all of the due words that we have to get through before we potentially introduce a new word. And finally, once we've finished that, we can now assume that our while loop is going to continually go through until we either finish all the words, we've mastered it, our space repetition algorithm is going to be applied to create this long list of words, and then when we finally break out of this while loop because we've learned everything, we'll eventually hit this little condition just here. Then we're going to continue on to the next set of code, which is where we can write this to our CSV file. Now this code is actually relatively straightforward. It does rely on an accessory function that we haven't completed just yet. But essentially what we're going to do is just first create a variable called output underscore file and set that equal to a string. And this string is going to contain the name of the file that we're going to write this information to. And that's going to be words underscore history.csv. Now beneath that, we're going to call on a function that doesn't exist yet. So it's going to be write underscore set underscore to underscore CSV. And then that's going to take some arguments. So we're going to have the circular parentheses, and in here we're going to throw in the history and comma separate the output file. So it's going to have 2 arguments. And what the function is going to do is it's going to write the history to the output file. And then the last thing we're going to do is print out, and we're going to call the len method, which calculates the length of an array or the number of entries within an array. And we're going to pass in the history. And so that's just going to print out to our terminal how long this list is that introduces all of these words according to the space repetition algorithm. And so the only thing we need to do to finish this is just write this little function here. Now, because I'm calling on it here, I have to define it above. So what I'm going to do is go up a little bit. And the place that I'm going to create this function, I'm going to scroll up to the top. And just here, where we have this function to load vocab from JSON, this function is kind of for interacting with files, so I'm going to create this other function which is for saving to a CSV file just beneath it. So we're going to use the def declaration for our function, and I'm going to paste in the function name, which is write set to CSV. Now we obviously have the arguments, and in here we finish that off with the colon, where the arguments is going to be the word set. And actually I'm just going to change this to list, because technically a set is a slightly different data type. It's similar to a list, except any duplicates have been removed, and that's not actually appropriate for us. So let's just change that to write list to CSV. And consequently, when we call it down here, after we've finished our algorithm within the review session function, I'll just update that function name to match when we invoke it. Anyway, so coming back up to this function, I'm now going to enter in onto a new line into the scoped block. We're going to tab across, and we're going to use the triple singular quotation to describe this function, which just writes a list of words to a CSV file with each word wrapped in double quotes. Now the reason we wrap words inside of double quotes is because it's just important for formatting in a CSV file, but that's not really a major detail. Now obviously this function takes the words list. It also has a second argument, which is the output underscore file, so that's where we need to write it to. And the logic is actually pretty straightforward. Just up here we had this with open line. Now what this does is it looks on our local device for this file, and it opens it up in either one of two modes, a read mode or a write mode. And then while it's open, we assign it to a variable name, and then we can, potentially either read data from that or write it to it. So we're going to have some similar logic here. We're going to say with open, and we're going to open up the output underscore file. Now after that we need a mode, and the mode is going to be equal to a string that contains the character W because we're writing. We're going to need another parameter that says new line equal to, and that's going to be equal to an empty string, and this is the character to denote a new line within our CSV file. And then finally, when we're writing to a file, we have an encoding. That's just going to be a character encoding, which is a string, and the specific character encoding we're going to use is UFT-8. Now with that file open, we're going to call it something, so we're going to say with open that file as file. So refer to it as file inside this scoped block of code. Now in here we're going to define a variable called writer and set that equal to CSV, where CSV is this package we imported ages ago. And we're going to say .writer, and in here, that's a method, we invoke it, we pass in some arguments. One is going to be the file, and the second is going to be quoting, and that is just a parameter that we're going to set as csv.quoteAll. Now this particular line says take all of the entries and just wrap them inside of double quotations, and we'll see what that looks like in a second. And all of this logic is just specific to this CSV package, so you could look up the documentation and it would explain how all of these lines work. Anywho, now that we have writer, what we're going to do is use a for loop that says for word in words underscore list. So go over every word in our words list, which is our history, which is our sequence of words that follows the space repetition algorithm. We just want to say writer.write row. So we're going to write a singular row inside of the CSV file. That's a method, so we invoke it with the circular parentheses. And in here, we're going to pass in the square brackets containing the word, so the individual word. And so this for loop is going to go for every word. It's going to build up this data, and then eventually we're just going to write it to the CSV file. And then once that finishes executing, it's going to save it to that file. And if we go ahead and save that, I believe that is our entire file complete. And we can go ahead and test it. Now, we've written a lot of code and we haven't exactly tested it a whole lot. So let's see if everything just magically works first time round. One thing I would point out is that if it doesn't work, Don't stress, that's totally natural. There might just be a simple syntax error. That's why my code is linked in the description down below inside of the GitHub repo. You can find it linked in the description. And you can always compare your code to mine to help you debug, find any syntax errors, any indentation errors, and all that good stuff. The very last thing we need to do before we move on is, we've completed this last step. So this saves this long list to a CSV file. So I'm actually just going to move that above this line just here, because that's where it's all happening. And now we've created this review session function, but we actually need to invoke it. And it's going to happen just where we basically kick everything off inside this if block. So the first thing we do is we get the vocab. And now that we've loaded all of the data, we can now run or invoke our review session function, and we can pass in the vocab cards as an argument, just like that. So we're going to pass these vocab cards in here, and we can see that the review session function doesn't in fact take the vocab cards as an argument. It also takes a max repetitions, but we can see that we have a default value assigned, so we don't need to input that. And now if I go ahead and save that, that is our code complete. So let's take a risk, go ahead and run it, and it should read our definitions, and we would expect it to output a file where the file name is words history, and it should have this long sequence of words. So let's go ahead and try. We're going to say Python 3 for me, or Python for you, and we're going to call chapter _2.py, hit enter, and we can see that I did in fact have, we actually reviewed a lot of words, so we actually made some good progress. However, we did encounter an issue, and that's because I used .value, and that is on line, it looks like 105. So let's go and debug that. And that's because .value is .values. So that was a little spelling error. And this is actually really interesting because it will be the first time that we've not had any due words, and we've also found that we haven't had a filler word. So I can tell you that we would have gotten pretty close. We were ultimately checking if we were actually finished. Anyway, so we got close to the end, but it didn't quite work. I'm going to make that change, turn that into values, save that, and run that once more. And now we can see that we did in fact complete that whole code base. We also printed out, just down here, you can see we printed out the length of history. And it came out as 3,520. Now inside of definitions, there's maybe 400 or 500 words. So that means that we've at least learned each word 5 times, sometimes potentially more. And we can see all the different words that we were reviewing here. And we also have this words_history.csv file. And if you come in here, you can see the order of all the words. And what we're going to do now, just in here, is check that they have all been introduced and tested at ever increasingly large intervals. So I'm going to test it with the word lugubrious. And we can see just here that we start off, we introduce the word. And then once it's introduced, we now have a word due. So the first thing we do is we test that word. So we show them the definition and then we test them on it. And then once we've tested them once, it's not immediately due. We have to give them some space, and the original spacing is 1. So in that time, we introduce a new word, and then after we've tested the new word, we then once again test lugubrious, and then it's time to test the other word we've introduced. And now, because both of them are on the back burner, we need some space until we test both of them again, we introduce another word. And if I Control C and then Control F and look up the word lugubrious, we can see that in total it's tested 9 times. The minimum a word is tested is 5 times, but because this one was introduced at the very start, we're going to encounter it more. And essentially, if we look at the index, first it's first, second, 4, 10, 33, 85, 285, 900. So that was a really big gap. And then 2,700. And so we can see that each time we encounter this word, we're spacing it out further into the future. And that increasing spacing is what's really going to consolidate that word inside of your head, testing it at ever increasing intervals. And that's how spaced repetition learning actually works. And you could do that for a bunch of words. Let's test the word interwove. So if we go back to the first encounter, we can see that we first encounter it at, index 2796. Then we encounter it a little bit later, and then the intervals continually grow, but not to the same extent as lugubrious, and that's because we introduced it later. But the point is that we still test this word 7 times. The minimum is 5. And so that's super cool. And the best thing of all is that now that we have this list, it's saved to our device, we're done with this file, and now we can jump into our play.py, and we can write the code that reads this list and test the user on these words until they make a mistake, at which time we then send them back to the very beginning and they have to go again. And each time they fail, they get a high score. The objective is to beat the high score, and doing this multiple times is just going to make them a pro at all of these advanced words. Now, objectively, this second file, play.py, which is where we're going to have the logic to read this list and test the user, is much easier, which is kind of funny. So at the end of the day, this file is actually going to be way easier to code out than chapter 2. But either way, both of these files are going to be a great resource that you can refer back to in future, because they just show, they're a great demonstration of all of the core concepts that we learned in chapter 1 that you'll need to go and build your own absolutely amazing Python applications. And so we should be able to absolutely rip through this file. Now, the first thing I'm going to do at the very top is import the necessary packages or libraries from Python that we're going to be needing. And one is import CSV, because obviously we're reading data from a CSV. But the CSV only has the individual words, it doesn't contain the information. And if we're introducing a new word, we need to show the user the definition. So we're also going to need to read in the definitions.json. So what we're going to do is also import JSON. Now, one thing I wanted to point out is that if the length of your file, when we printed out the length down here, if it's different, don't worry, I've gone and fiddled with this definitions.json file since I've uploaded this course, just to make sure that I'm happy with the definitions and the words that are included. Some of them were perhaps a little bit easy, so I wanted to make sure that they were all truly complex advanced level words, and that the definitions were short, because obviously if we're testing a user, you can't have a 3-sentence definition, because it's just going to be impossible for them to actually remember that repeatedly. Anyway, we're going to need these 2 libraries. So that is done and dusted, super easy. Now, obviously the big step is to create a game where a user has to get through as many items in the list, i.e. answer them correctly, and then when they ultimately fail, they get a high score and have to start again, which also forces them to continue practicing. So that's the overarching objective of this file. Now, step 1 in there is to create functions to read both a long list of space-repeated words, so that we loop over them and test the user continuously until they fail. So really, this is what we need to read both the long list. And we also need to read the definitions. So let's do those 2 functions first. So function number 1 is going to be def, and that's going to be called load underscore words underscore from underscore CSV. It's going to take some arguments, which is going to be a file path, and then we're going to have the colon at the end. And we're going to just give a label for the argument of file path. Now in here, we're going to have the triple quotation, because we're going to add a description. And this just loads a list of words from a CSV file. Easy money. Now, because we're reading files, we're going to use that with open syntax. So we're just going to say with open, we're going to pass in the file path as an argument to this method inside the circular braces. And we have a secondary argument, which is the mode, which is going to be to read. That means that we're not actually writing the file, we're just reading to it. And then we're going to say open this file as f. So f is going to be the name that we assign, and then we're going to have the colon. And in here, in the scope code, we can do a whole lot of stuff. We can read the data. So what I'm going to do, since we're reading from a CSV, we're going to define a variable called reader, and that's going to be equal to CSV, and we're going to access the .reader method, invoke it with the circular parentheses, and pass in the file. So this is going to open the CSV file, and then this line is for reading the CSV data, the comma separated data. And now what I'm going to do is I'm going to define a variable called words, and that's going to be an array. And what I'm going to do is read every line inside of the CSV data and add it to my words array, and that's going to be my data. So I'm just going to say for row in reader, where reader is our data, and each row is literally a row right here. So we have one row, we have another row. So we're going to read in each row one by one. For every row in reader, we're going to check if the row actually exists. Then I'm going to have some code scoped to this if block. I'm going to say words, and I'm going to .append, call the .append method. We're going to invoke it with the circular parentheses and pass in the row, and specifically the 0th index, because a row could technically have multiple entries. We want the first entry, which is going to be the word. And what this code is going to do is it's going to go row by row in the CSV file, find the 0th entry, which is the very first entry, which is kind of confusing. 0th indexing systems can be confusing, but at the end of the day, the 0th one is always the first, is literally the first one. We're going to read that word and add it to our words list, and that is going to be our data. Now at the bottom of this code, after we've got words, we've gone over this for loop for every word or every row inside of our CSV file. We can just now return words, and that's going to spit out all of our words, our list of words, our array of words from this function when we eventually call it. So that's for reading for the data. Now we have to define a second function called load definitions underscore from underscore JSON. And that's also going to take a file underscore path, and then we have a colon at the end, and the file path goes within the circular braces where we provide the input. Now in here, we're going to have the triple quotation, and we're just going to say load the definitions from a JSON file. And this code is pretty similar. We're just going to say with open, invoke the open function. We're going to pass in the file path, which is the file underscore path as an argument, and that's going to locate the JSON file when we eventually specify the name of that file. We're going to have the comma R parameter, which just means that we're reading this JSON file, not writing to it. And we're going to say as if, label that open file as if, have the colon, and then in here what we're going to do is create a variable called definitions and set that equal to, and to read a JSON file, we call on the JSON package, which we've imported up the top, and we call the .loads method, and we load the file f. And that's just going to read in our JSON and also pass it and turn it into an object that we can interact with. That object is going to have a whole lot of key value pairs, just like we have here, that we can then interact with inside of Python. Now that we have definitions, after that's open, we can just return definitions from this function. So when we call this function and pass a file path, it's going to read the JSON and spit it out, and then we can access that data, the definitions data, wherever we need it. So now that we have these two functions, we can now define a continuous while loop that tests the user on each word in the list. Now this is also going to be a function called def, and that's going to be named test underscore user. Now we have the circular braces. This is going to have some arguments as well. It's going to take our list of words, and it's also going to take the definitions, ensuring we spell that correctly, definitions. And then we're going to have the colon at the end, and that's going to have all of our code block. And I'm just going to, for the second, return out of here, because if we don't have a singular line within inside this function, it's going to be unhappy when I write code beneath. And that's going to sit as a placeholder just while we write the very last line, which is going to be the same weird line that we had at the bottom of our chapter 2. And it's going to say if underscore underscore name underscore underscore is equal to quotation underscore underscore main underscore underscore, and then we have the colon at the end. Now if you recall how that works, when we run a file directly, so when I say Python 3 and I specify the play.py file, this variable name, which we've never defined anywhere, but it's kind of like a special variable, automatically assumes this weird name underscore underscore main underscore underscore. So essentially what this line is doing is it just confirms that we're actually running this file specifically. However, in an alternate case, what could happen is I might have some logic in here that then gets run vicariously from another file. In such a case, this parameter would actually assume the name of the file. So it would be play.py instead of main. And if that happens, then this condition would not be true, and so we wouldn't enter any code down here. We wouldn't run any of these functions. We would instead just run them in some other file. And so this is convenient because it means that we can define all of these functions and have them available anywhere, but only actually run them if we call this file directly. So in here, what I'm going to do is have a comment that's just file paths. So we're going to have some logic for the file paths first. So I'm just going to say, I'm just going to create a variable called csv underscore file underscore path, and that's going to be equal to, and we can see it's called words underscore history dot csv. We're also going to have the json underscore file underscore path, and you can see that I like to be pretty explicit with my variable names because that's just one clean code best practice, and that's going to be equal to a string containing definitions.json. So these are our two file paths. Now underneath that, I'm going to have some more code, and I'm going to describe what it does, and it's just to load the data. And so in here, I'm going to create a variable called words, and that's going to be equal to, and we're going to call our first function, which is to load words from the CSV, and we're going to pass in the CSV file path as an argument. And because we return something out of that function, it gets left in the place of this function invocation, and then we can assign that value to the words variable. Underneath that, we're going to do the same with the definitions. Create a variable called definitions and set that equal to, and we're going to invoke the load definitions from JSON. We're going to call it with the circular parentheses, and then we're going to pass in the JSON file path. And that once again is going to return out our data, and then we're going to assign that to this variable. And then finally what we can do is have another comment, and that's just going to say start the game. And up the top we're going to have a print statement that just says print welcome to the word definition game, exclamation mark. And that's going to print out, and then after that we can call the actual function to start the game, which is test user, and we just pass in the words and the definitions. And so what's going to happen is when we run this file, we're going to define all of these functions, and then eventually when we hit this code block, this is when we really kick it off and start everything. Up until here, we've just been defining stuff that isn't actually being used. But it's when we hit this code block, first we're going to actually create these file paths, then our Python is going to load the data, then we're going to print out this line, and then we're actually going to kick off the game. So now all we have to do is finish this last function that's called test user, and it's relatively straightforward. So in here, we're going to have the triple quotation, and we're just going to say that this function test the user on the words and their definitions. Pretty straightforward. I'm going to remove this return line because it doesn't actually need to spit anything out. If you see just here, we're just calling this function to invoke it. We're not actually trying to leave anything behind that we assign to a variable, so we don't need any return statements. And that's actually not entirely true. We will need to return out of this function when they make a mistake, because that essentially ends the execution of this function. And so in here, the first thing we're going to do is have a variable called top underscore score, and that's going to start off being equal to 0 because obviously we start with a score of 0 and then we work up from there. And I'm also going to test the encountered underscore words. So I'm going to create a variable called encountered underscore words, and that's going to be equal to a set. Now we're going to call the set function and invoke it with the circular parentheses. And I'm going to leave a comment here, and this particular encountered words is going to track which words the user has already encountered. Now, as I said just earlier, I brushed over it very briefly. I said that a set is kind of like an array or list, where it's one thing after another. except all the values inside it are unique. So we could have a list that has multiple duplicate entries, but if we were then to convert that list into a set, it would remove all the duplicates. And this is super cool because when we're testing a user, we need to keep a record of which words they've encountered so that we can see, oh, this user's never seen this word before. Let's show them the definition because it's the first time they're being tested on it. So now that we have these variables that we're just going to need for convenience throughout this little game, we can get to the logic. So we have all the words being provided as an input or argument to this function. So we're now going to need a loop that loops over every single word in that list and tests the user one after another. So we're going to have a for loop because we know for how many iterations we want to run this loop for all the words in the words list. So we're going to say for word in words, colon, and then we're going to have some code that is scoped to this for loop. So first what we're going to do in this game, the user is going to interact with this game via the terminal. So the way that we're going to communicate to them the instructions, what they need to do is via a whole lot of print statements. So first we're going to print a formatted string. So we're going to have the F key, and then I'm going to have the quotation mark. Now in here I'm going to start off with some special characters, specifically the \n. Now what this character does, the \n, is it just enters, it says new line. So if we're printing, it just inside of our console will put us onto a new line. And then after that character, I can say word, colon, space, and because this is a formatted string, I can inject a variable into it. So I can use the squiggly parentheses and I can just pass in the word. And so this code alone is going to go over every word and print them out on a new line saying this is the word and then this is the actual word. So this could potentially be replaced with the word lugubrious or whatever word it is that we're being tested on. Now underneath that, what I'm actually going to do is have what's known as a guard clause. So here I'm going to say if we have a word that isn't defined, skip it because it's an error. So this is kind of just a just in case. We've accidentally got a word in the list that isn't actually defined, then we're not going to be able to test a user on it. Now this line is a great example of why so many people love Python. Now this particular line is actually a great example of why people love Python because it's pretty much English. And this condition just checks the word, and we could have the syntax that just says is in definitions. So that checks if the word is in definitions. But if we just throw the not in front of it, then it's going to invert that condition, and this is just going to return true or false depending on whether or not the word is in the definition. So if the word is not in definition, if that statement is true, then in here we're just going to print out definition not found for this word, full stop, period, and then I'm just going to say skipping ... Now because of the way we've created this list, which in this other file is actually based off the definitions, I wouldn't expect this to be true. So we should never theoretically see this coming, see this output, but just in case we went to meddle with the definitions and we ended up with a word that wasn't in fact defined, this is good. This is just good error handling. So if we get past this line, we can confirm. So here I can say can confirm word has a definition. So we can test a user. So what I'm going to do is access the definition. I'm going to say definition, create a variable called definition, and that's going to be equal to, I'm going to access the definitions dictionary, which is an object of key value pairs. The key is the word, the associated value is the definition. So I'm going to access this object, and I'm going to use the square parentheses to look up a value, and I'm going to look up the word. And so we're going to look up the word inside of definitions, and that's going to return the actual definition. We're going to assign that to the variable definition. Now underneath that, I'm going to have some code that says if it's the first time encountering the word, show the definition. And that makes sense because if it's the first time they're seeing a word, we need to introduce them to them, tell them about it, and specifically show them the definition. So we're going to say if word, check the word, and see if it's not in our encountered words set. So that's going to look for this set and see if the word is in it. And if the word is not in encountered words, then this is going to be true. Enter this code block, and then we can confirm that we haven't seen the word before, so we need to show the definition. So here, I'm just going to print a formatted string that just says the word, and then it has the colon. Well, actually, I'm going to make it a bit clearer. I'm going to use the little dash and then the greater than symbol, so we have an arrow, and then I'm just going to have the definition. And so inside of our terminal, we would print out the word and its associated definition, so a user has some reference material. Now underneath that, even if it's the first time they're encountering this word, I still want them to actually enter it in the terminal so they get some practice for next time. So what I'm going to do is I'm going to say user underscore input. Now we haven't seen this before, but what we're going to do on this line is prompt a user to write something. And then we're going to gain access to what they've written and test that they've written out the definition correctly. So we're going to create a variable called user input, and that's going to be equal to, and we're going to call the input function. So this takes an argument which is a prompt. So what's going to happen is we're going to provide a prompt to the user, and then the code is going to pause executing until the user has written out their answer in the terminal, at which point whatever they write will be assigned to this variable user input, and we can then go and test if they've written the answer correctly. So in here as an argument, I'm going to provide a string which is going to contain the prompt. So up here, we can see that we have this word. That's the first thing that prints out for every word that we're testing. Now what I might actually do is change this to say define, have a colon, and then the word, because that's actually going to make more sense. And then, so the define is going to print out. We're probably not going to encounter this print. So the next thing that's going to print is the definition, if it doesn't exist. But if we're in fact testing it, then what I'm going to do just here is have an answer, and then a colon, and then a space. And so what's going to happen is for every word, we're going to print out the instruction, which is to define the word. If it hasn't been encountered before, we're going to print out the word and the associated definition. And then we're going to print out a prompt that says answer, and that's where they're going to provide their answer, which in the case where we do print the definition, they can just copy it directly. And if we don't, and if they've already seen it, then they just need to be tested on it. So now that they've answered, let's say they've typed out their answer, and that's been assigned to this variable user input, we can now check if it's complete. So we're going to say check if the user input matches the definition. So in here, I'm going to say if access the user input, and I'm going to call a .lower method. Now what .lower does is it just converts the entire string to lowercase, and this is important because we don't want to test them on casing. That's kind of like a moot point. We just want to make sure that the characters used in that definition are the same. So I'm going to convert both the user input and the definition to lowercase so that we get a better comparison. What I'm actually going to do in here is check the opposite. So I'm going to check if they made a mistake. So if the user input is not equal to, so in this case I'm going to use the not equal to equality check, and that doesn't use the not keyword, it instead uses the exclamation in front of the equal sign. And that's the opposite of the actual equality check. So this is to check if two things are the same. This is to check if two things aren't the same. So if the user input is not equal to the definition dot lower, so that's going to convert the definition to lowercase as well, then I'm going to have a colon, and in here, then the game is over. So I'm going to print out game over exclamation mark, and at the start of this, I'm also going to use the \n key to enter this onto a new line inside of the terminal. That's just some text formatting. And then what I'm going to do is print out some information. So I'm going to print a formatted string. So I'm going to have F and then the string. And in here, I'm going to print out the top score, colon. And then I'm going to have a space, and I'm going to inject the top score. Now, we don't have the logic to modify the top score yet, but that's because we also haven't handled what happens when a user has a correct input. But we'll get to that very shortly. For the minute, we're just handling the case where they make a mistake. So if they were to get the very first definition wrong, we would end the game and their top score would be 0. We're also going to print out the word that they failed on. So this is going to be a formatted string as well. And I'm going to say you failed on the word, have the colon and then the curly braces, and inject the word. After that, I'll print out the word's definition. I'm going to say a formatted string, print formatted string, correct definition, colon, and then in here curly braces, and I'm going to have the definition, inject that into that string, and they'll immediately be able to compare what they wrote above to the correct definition. And the last thing that's important here is we need to have this return keyword. And when a function encounters the return keyword, this return keyword is the child of this test user function. It ends the execution of the function. So the game is over. We don't want to continue this for loop. So it's kind of like the break keyword. Instead of except of just breaking out of the loop, it ends the entire execution of the function. And then this line will go on to the next one, and the Python file will finish executing. Now let's say this isn't true because they've got the answer correct. Well, what happens then? So here, what I'm going to do is add the word to encountered words and increment the score as they answered correctly. And that's pretty easy. All we do is we say encountered words dot add. Now when we're using a set is kind of like a list and an array, but it's not quite the same thing. And so we have slightly different methods to add values to the end of a set. Now with a list, we use the dot append method to add something or append it to the end. Dot add is different because if we try to add something that already exists in the set, it's going to be ignored. And all we do is we add the word to the set, so that if we're encountering it for the first time, it's a new entry in the set. But if we're encountering it, but if we've already encountered it, then it's not going to change the set. And the reason this line is important is because if it is a new word, we need to make sure that next time we test the word, that we don't show them the definition. And then after that, we can increment the top score. So we can say top score plus equal 1, which just adds 1 to the current value of top score. And we can just say, we could print out correct, exclamation mark. And that is going to handle the logic for a correct answer. And then the very last thing we need to do in this file, let's say we get through every word in words. So what I'm going to do is come down to the end of this for block, which is going to be just here. So here I'm going to have a comment. We have finished the entire for loop, completed every word in the list, and the user has won the game. And so in here, I'm just going to have a print statement that says \n for a new line. Congratulations, exclamation mark. You have completed the game, smiley face. And then underneath that, what I'm also going to do is print out the top score. So I'm going to have a formatted string that just says top score colon space and then the squiggly parentheses, and that's just going to print out the top score. And that is going to be the very last thing that prints when we finish that for loop. We've confirmed that they haven't made any mistakes. They've mastered, or they've been tested 3,520 times, got everything right. They've mastered all of these words. And that is the end of that function, and consequently this file. And since we now have our history of words, we can go ahead and start testing ourselves. So to run this file, I'm just going to type Python 3, and then we're going to type play.py, hit enter. Oh, and we got an error. Let's go ahead and debug it. So it looks like it's in line 19, load definitions from JSON. So we made a mistake in here. And the issue is that I've used .loads where it should just be .load. cheeky syntax error. That's all that was wrong. So let's go ahead and use the up directive, the up key, to find that command again. Go ahead and execute that. And we can see now we're printed out, welcome to the word definition game. It's telling us to define lugubrious. And here we have lugubrious and the associated definition because it's a new word, we haven't encountered it. So I'm just going to cheat. I'm going to copy that definition and paste it in as my answer and then hit enter. And we can see that was correct. And now it's testing us on that word. So I'm just going to cheat a little bit. I'm going to copy and paste it in again. And then we got that correct, so we move on. Now it's telling us to define a water. First time we've encountered it, I'm just going to... You really shouldn't be cheating at this point, but you get the idea. I'm going to copy and paste that into the answer, hit enter, and now it's testing us on lugubrious because we got that correct. So I'm going to say gloomy, comma, mournful or dismal, comma, especially to an exaggerated degree, full stop, hit enter. Now we're being tested on water. A guard, especially in a prison, full stop. And then we're being tested on beset, to surround or hem in, full stop. First time encountering that word, so it shows the definition. And I got that wrong. And that's because I said him. And we can see that I got a top score of 5. It tells me the word I failed on, and it gives me the correct definition. And then if I wanted to play again, I would just run up, re-execute the file, and so on and so forth. And that is our absolutely brilliant project. If you've reached this far, congratulations on getting to the end. I hope you've thoroughly enjoyed the course. There's some complex code in here, so full credit to you for persisting to the end. I'd highly recommend taking some time just to review what we've done. A good exercise to see if you could come away and in a file just even write out the steps that we took to create this project. Reading the data, writing the data, defining the space repetition algorithm, all that good stuff. I hope this code base serves as a really good point of reference for you in future if you're using Python. Be sure to upload it to your GitHub pages so that it's stored forever. If you want to tag me on social media and share your project repo with me, I'd love to see it. Pretty active on LinkedIn. You can tag either myself or the Small James Education page. That would be super wicked. And if you do want to support me, be sure to smash the like and subscribe buttons and also star the GitHub repo, which is linked in the description down below. Python is so absolutely brilliant, and there's 101 million other things you could do with Python. This course was just to demonstrate a lot about the Python syntax, a lot of the cool things we can do with Python, and hopefully with the skills you now have, you feel confident and comfortable going forward, developing all sorts of other amazing Python applications. Thank you guys so much for watching. Love sharing this stuff with you, and I'll catch you later. Peace. Learning to code? If so, be sure to check out the Learn to Code roadmap or dive straight in with these videos. That's a good